Ma'am.
Do you have profile? इंट्रोड्यूस कराएं तो प्रोफाइल कौन है लोबना जो
Lubna को कौन है but माँ generally लिखो है.
that 02 CS batch yeah.
Okay.
And now she's a faculty member. She did PhD in cloud computing.
You will know.
Okay. Okay, right. That will be a proud moment.
Yeah. That's right.
So, dear fellow students and our guests who have arrived from Karachi, so very good afternoon. I think you have taken lunch, but our lunch is light, so I don't think anyone feels sleepy. Even our guests, they also had a very light lunch. So I feel proud that next speaker is again one of our alumni, Lubna Lakshmi Durani. She's 02 CS batch graduate from Iran. Then she did some MBA diploma from Zabis, Karachi. After that, she got a scholarship to do masters in business IT from Southampton, partial scholarship, not a full. And then she joined ISRA University as an assistant professor for a year. Got married, so she has to leave back to Dubai, went to there, spent some time with in-laws, families, and then she used to teach Zabas Dubai as well. But she wanted to do PhD, so she has been working, writing to several professors. This is I'm mentioning you because this morning we got one of the speaker and Mrs. is also there, and when we were discussing, she said you are a firm believer of the woman empowerment. So you know, it's one has to appreciate in our society how you have to encourage, motivate female to do such type of academic and research position tasks. So she got a scholarship with her boy of 2.5 years. She went to Ireland. She completed PhD 2 years back. She was offered the postdoc. She carried out 2 years postdoc, and Now she's going to start her lectureship position soon at the university there. So it's my pleasure to welcome Lubna, Dr. Lubna, to deliver her talk on the topic she's going to show. That's very emerging project she has been working, and it's very relevant to all our industry needs, the security and industry 4.0 security. That's one of the important issue, and having more huge job opportunities there. Thank you. Over to Dr. Lubna.
Thank you very much for the nice introduction. I'm delighted to speak on this platform and be here. And I hope by the end of this talk, I leave some good points for you and trigger some good thoughts, some creativity in students out there. So I'll just briefly introduce myself. I'm Dr. Lubna Lakshmi Durani. I finished my PhD in cloud computing into 2019, and that was mainly towards cloud standards, quality of service, and how to mitigate the security issues considering cloud SLAs. Based on my research, I was offered a role in a postdoc role in data and network security. So I moved straight away in Industry 4.0, a real industrial project. So, and yes, I'm finishing handovering this project and moving into my new role. So just, you can see here, this is a research center which comes under University of Limerick Confirmed Research Center for Smart Manufacturing. So here are where all of our projects come for manufacturing, different type of AI-based projects, big data projects, security-based projects, IoT-based projects, any type of manufacturing projects. So currently the one that I'm working on is a J&J Johnson & Johnson-based project, and I'm designing a security strategy to secure the machine-to-machine communications in Industry 4.0. So I'm focusing on IT and OT security, not just one aspect, just two different aspects of security. And then we have different projects going on in Center of Robotics and Intelligent Systems, which is a part of our research. So we have different type of research going on out here. The current role that I'm moving here is I'll be teaching micro-credentials type of modules in Cyber Skills Island, which is a national project. There are 4 universities inside it: University of Limerick, TUD Dublin, UCD, and then MTU. It's a joint project in which we'll be directly teaching to industry. So it's a kind of, with the current cybersecurity need that is going on, you can see by next year, we will have 3 million deficit. We might need 3 million more people, graduates, for cybersecurity based roles, but it's hard to just produce them overnight. So what the current approach we are doing is offering these courses to straight away to people who are working in industry, level 8, level 9, level 10 based of courses, straight away offering it to them. So upskilling, this is the main concept. So you can see here, I've put a news clip of a press release of the next project, the 2 projects that I'm involved in. The second one is cybersecurity apprentice program. So filling up the skill gap that is currently within this market. So if your students are looking forward into cybersecurity, there's a huge scope for you out there. So moving ahead into today's talk out here is, why is cybersecurity important? So we have, with the increasing use of IoT-based devices, you can say, before you can say the figure was around 5.4 billion, but right now that within 2 years or 3 years time, this figure will go to 20 billion connected devices. So which each of these devices, these are end nodes connected within either a manufacturing environment or industry 4.0 or any type of environment, you can say. These end nodes, they're very vulnerable in terms of how are they secured, how are they patched, how are they updated, what type of antivirus. Now, if you're implementing, you have so many IoT-based devices in your organization, you won't be buying them from the same manufacturer or from the same contractor. So definitely it's subject to different standards. So these types of devices are really vulnerable. You have to look into the security of these devices because they're directly communicating with the machines out there. So you have to look, your IT and OT need to be aligned and secure. Now we have sensitive systems, we have different type of strategies are required to secure these types of environments. We have seen this in the recent increase of, you can say, the Colonial Pipeline, or you can say the Microsoft Prince Pooler type of breach, different breaches that have happened in the last 3 months, and the amount of cost it has produced. So if you lose your data, or if your data is compromised based on GDPR, or that, it can cost you huge fortune. So it's better to invest into security instead of putting your data at risk and then compromising your own environment. So we have different type of things, like the most recent increase one are phishing, wishing, phishing, and social engineering type of breaches. So you can see here, I put up a person here, like 81% of times there have been successful attacks on usernames and passwords, or somebody has clicked on an email, or there has been a drastic increase in computer viruses out here. What we're talking about is around 2,200 attacks per day, which means 2 attacks happening every minute. So this is the amount of security you can look in, even no matter how good you're updating your antivirus, you're updating the definition. But again, with so many pieces of malwares being coming up every day, you can't protect your environment in just one way. So you have to look at a certain cybersecurity strategy, design it. Again, one important point to note here is one model doesn't fit all. In project management, it's a very famous quote. Similarly, each enterprise, each industry, if it's a manufacturing, or if it's a smart grid, or if it's an IT firm, or if it's the data is on the cloud, you have security would be different policies, different protocols would be implemented to it. Moving forward, you can see here, so the average cost of a data breach is 3.86 million as per 2020. You can increase the figure out here. So 80% of reported incidents are mainly based on phishing attacks, but again, social engineering call. Okay, somebody can say, okay, I'm from the IT section, or I need I have an upgrade going on here, and so there is a lot of lack of awareness, and people they're so convincing, they manipulate and getting information, and they enter it. Or one of the other is either it's a accidental or a malicious insider. You accidentally click onto it, or there's a former employee who's left there and whose identity and access management hasn't been controlled. The rights that were given to him. Usually most enterprises, what they do, they create an identity, they create an ID and email and access, and once the employee is leaving, they don't close that account. And this is one of the most common places how hackers or breaches happen inside organization. So looking at the globe, I'll just leave the figure to you out here. You can see we are putting banks at risk, we are putting our manufacturing, we are putting our healthcare system at risk. So our whole infrastructure is at risk if we don't take cybersecurity important. So how is it changing from what we were 10 years back and where we are going? So you can see this is industry 2.0, what we're talking about. So everything is behind. This is probably, you can say, our SCADA, our PLCs, and these are applications, and there's just one firewall. And you can talk about this as a traditional internet, or the Ethernet connectivity that we're having out here. And what we're moving here is we're moving to a 5G, we're moving to self-driving networks, fully connected, fully automated environment. So your factory can be anywhere. It will be enabled through novel communication methods. We are moving data onto our cloud. So where something that was only kept in-house is now moving on the cloud. Based on how the industry is moving, we have to get more versatile, and that's where things become more complicated, because something that was only, you can say that you have a university or you have a house which is completely fenced, so you just have to look at the security at just the entry point at where somebody's entering and exiting. But right now what we're doing, we're putting the whole environment in the open, and you have to look at different angles to protect it from how the data is, when the data is at rest, when the data is at transit, when the data is being processed. So it's a very complicated thing you have to look into. So we're moving from 1970s to here to a fully converged environment. So looking at this type of, you can see fully connected, fully automated, scalable, agile. So you can see here, the common example I would give out here is manufacturing is not just happening, it's not just happening in a factory. What we're looking into the future is a factory can be set up anywhere. Anywhere means in a desert, in a remote location, in the mountains with 5G, with Wi-Fi, with different supporting technologies. It's your operations to be facilitated anywhere. Let's say there's a requirement of manufacturing prosthetics in a hospital. So you put up your you put up your factory in a pod, in a container, and you just it's fully connected, and all your machines are down there, and you just deploy it there, and then it starts, manufacturing over there, and it goes straight to the hospital, filling either there's a biomedical need or biomedical application. So you're manufacturing straight there, your robot arms and every setup is there, and your data is going straight to the cloud. So you see, so we're making it more scalable. So the time to reach market, let's say if the prosthetic is in one country and it has to reach the hospital, the timing is 2 months. We have reduced it to probably a matter of days. So this is what we're talking about agile. The second security thing that out here we have to is, we have robot arms in industry 3.0, which are controlled within cages. Here we are moving it. The robot arms have the understanding of working with humans. So there'll be no cages. So each robot arm is around, you can say 40 kilos or 50 kilos, and the amount of pressure it's taking, it's moving. And if we take the cages out, and at any stage, if there's loss of process control, there's any downtime or any integrity type of breach, we are not talking about defective products or defective services or downtime. We are talking about a human loss. And that is which we want to prevent at every stage. So in terms of cybersecurity, we're looking into cyber hygiene, privilege, which I talked about, identity and access management, who's accessing it, looking into zero security, micro-segmentation, looking into every aspect of it, encrypting data, securing data when it's at rest, when it's at transit, when it's being processed, multi-factor authentication that we're using these days for our email. So for these sensitive systems, because there may be this factory and it's being controlled from a very remote country or a remote place. And then patching, so that each time the vulnerability, if there's any, we're just putting up layers on top of it, having backup of our data and training, creating more awareness into our employees so that they're updated of different type of security breaches. You can see here the average cost of losing sensitive information as per Gartner is $4 billion, which is huge, it's massive. So different type of NSL, which is it's provided it provides this standard. It's a standardization body, so it gives standards for 5G as well and security controls. And they've given this common thing out here as the most common type of breaches that happen here. And it is subcategorized here that it can be malicious code, it can be denial of service, or unlawful interception of data, or abuse of authentication, or virtualization threats that we're putting data into the cloud. So we have to look at cybersecurity in different aspects, like what type of attacks are they? Are they active attacks or are they passive attacks? Active attacks are those which happen directly, into a system. The ones, especially the rebel, you can say that is happening these days, is you can say it's an active attack, it's happening. The passive attacks are one is, let's say there's a backdoor, there's a software vulnerability or open door, and the hacker comes, he sees your environment, he enters your environment, he leaves the environment, and he keeps eavesdropping on you, he keeps looking at you, what you're doing. So by the time, it may be 6 months down the lane when the attack actually happens, but meanwhile, he's analyzing your whole environment. So it's a continuous breach going on. You have a malicious person over there. What type of data is he looking over? The same thing happened in the Danish bank, in which they had a passive attack. The Russians were looking into their environment, the banking environment, for up to 6 months. So you say how big the damage could be. Even if you change your whole security system, they know your infrastructure. You can't change your infrastructure overnight. So you can see there's a factor out here that 30% of industrial IoT attacks go undetected for up to 3 to 6 months, and by the time you realize it, the damage is already done. What we're looking on more of to controlling the loss of process control, having a resilient environment, so there's less downtime. There's looking into the different aspects of third-party dependencies, what type of softwares and things you're using and how to secure those type of things. So even if you have best efforts, they still leave vulnerabilities in the environment. So you have to understand the environment that you're working in, and design a security strategy up to it. You can't just say, okay, I have ISO 27001, or I have COBIT, or I have IEC 62443, or I have NIST, or I have a certain standard, and all my security issues are done. No, each enterprise is unique. You have to identify where the gaps are and then mitigate them. I'll be talking about the gaps in the later stages. So we're looking into confidentiality, integrity, and availability. So these are the three main security aspects that we are looking into. Moving forward, you can see here, this is one of the infographics that is from one of my journal papers. So I've put up here one of the most famous industrial control systems attack that happened till date is the Stuxnet, in which their whole nuclear facility was compromised. A worm was injected through a USB, and the nuclear facility, the way the uranium within the missiles, it was tampered. So even though it was showing that the system is right, but the quantity over there, it was fully compromised out there, and they couldn't use those types of missiles or something. And by the time they identified the issues, not only the facility, but the manufacturers who were providing, even this site was air gapped, it was remote, but still it was compromised. So there are so many other examples. You can say water utility company over here, hackers gained remote access to a SCADA system, and their water filtration system was, manipulated. You can see here smart meters, and then we have a Trojan entering black energy, which had affected. It led Ukraine, leading to power disruption in the region for half of the population. So we're not talking about small issues. You can see here BMW, researchers, they had ways to increment it, how to unlock the cars remotely. And this is why BMW, and this one more car company, it's not coming over my mind right now, they had to recall their cars, and they had huge losses based on that. Then sniper rifles, researchers found vulnerabilities of within the softwares in which they could affect how you aim at it. So it's a very big security breach. If these type of things happen, the very recent ones we can talk about, Florida water treatment, the VMware vulnerability into the remote portal, or the colonial ransomware supply chain attack, or one of the biggest ones happening in Ireland, HSE, their healthcare system was compromised through a ransomware. So, if you don't invest much into cybersecurity, you will pay hell more on ransom, getting your data back. So it's better you invest in the right thing instead of going for ransom. So as I mentioned before, so NSA has provided a threat landscape, and which they keep on updating. But there's a very big figure I would like to put up here is you can see that around 48% of the manufacturers, they do have cyber attacks, out of which 24% they do lose some sort of data. But I think within the current landscape, this figure would drastically increase. We have a number of standards, like we have for IEC 62443, we have ATSI 12M, we have NIST 80053. We have NIST cybersecurity, we have IASF. So there are a lot of standards out here when you look into bridging the IT/OT gap. Now, one of the things you can see out here that there are different preferences within IT/OT. IT focuses more on confidentiality of the data, that the data is protected, nobody's eavesdropping into it. Whereas OT looks more into availability of the data, that every time the systems are up, whereas they don't look much into the confidentiality. Reason being, there's a timestamp measure out here due to which confidentially, it's not an issue out there. So, so these systems, they currently, they look at these systems as they assess them differently. The standards are different. So this is why the gaps come up, and there are a lot of vulnerabilities moving forward to Industry 4.0. Now you can see out here, I've put up this diagram out here. This is OT, this is IT. These are the levels at which we're looking at, securing the systems at different levels. And then you can see the major focus is zero time downtime for process control, whereas here we're looking into confidentiality and data integrity. So you can't consider these SCADA system, PLCs and sensors, and then these devices separately. So currently there are different preferences, different teams working on IT, different teams working on OT. So there are different skill set, they're implementing different standards there, they're implementing different standards there. So even if you have different standards on your IT or on your cloud mechanism, you all have same metrics such as availability, such as assessing the service metrics. So you need to benchmark them similarly. I'll be showing that to you in the coming slides, how it happens. So this is where I'm bridging the gap. I'm designing a security strategy, aligning it with how the enterprise is working, what type of systems they're using, where their system, what type of environment they have, what type of connectivity they're using, and then providing security in that way. In the current landscape, you can see only 89% of the industries are aware of how important data standards are, but barely 11% of them are implementing. And we are seeing that based on this infographic, you see how many companies and enterprises can be breached. So now we're looking into increasing these policies, so that increasing these figures, so that in future we don't have to mitigate the potential breaches. Okay, so this is giving you an idea as what I was talking before as factory of the future. This is how it's not just going to be. You can talk about a smart manufacturing factory in a physical location and a smart manufacturing factory in a box, in a pod, or you can say in a container. And then over here, I've blurred this image because it's due to data protection. And we have machineries out here, and then what we're looking into, what type of communication technology that needs to be enabled. And then we're not enabling it with just with just 5G. We're looking into coexisting and complementing multiple standards out here, communication technologies, such as having it enabled with 5G and Wi-Fi 6 working together, or 5G and TSN working together, or 5G and self-driving networks, AI-based self-driving communication networks working on it, such as there's Juniper networks, or these types of technologies. So they can, so just in case if 5G is not available, our factory is still working, still functioning. And then looking into different security controls and security metrics. So one of the biggest things I've highlighted here, because of lack of standardization, is difficult to classify the right threat impact. So if the breach has taken place, how was it? Was it a red alert? Was it an amber threat? Or is it a low level threat? So what was it? Low, medium, high? What type of threat? How frequent was it? What was altered? What was manipulated? And identifying the breach before the damages occurred. So going into data forensics, looking into benchmarking how it's going, and making a resilient environment. So just to there's a word for it, what you say, kind of just to neutralize the threat. Yeah, that would, I would say that word. So once a threat you see, there's going into more of a proactive approach instead of going reactive. So in terms of proactive, we're looking into MITRE attack framework, or looking into IBM X-Force. Okay, so moving forward, we're looking into security standards, secure deployments, and secure operations. It's an ongoing process. And you can see out here, so this is where I'm moving forward, looking into overlapping different type of security standards. And you can read more about it on my research paper out here. So identify the different type of security breaches, assess them, align them, and control them. They're essential and mapping the different standards to fill in the blind spot that are there in this type of environment. So this is our current environment that Fraunhofer is providing the standard. You can see here, ISO 27001 and 62443. But what we require here is all different type of standards being mapped to mitigate the current in Industry 4.0. There's more and more that we need to do in layers. So you can see here is we have if there are this type of standards being used, you can see the coverage out here is weak. Then as the enterprise is more mature, they go for more type of security controls and look more into multiple standards and aligning them. So you can see over here is we have multiple standards out here, and then this is how we map it. So this is an example, and the details are provided in the paper. I think I'm running over time, so I'll just go over this a bit quickly. So the novel aspects I've already defined, you can see here, we're looking into creating value, visibility, and insights, simplifying the process, looking into cyber value that is at risk, invest more into cybersecurity. So there's, balancing the IT-OT convergence so that, this is how we protect the business value. Looking more into incident response time and aligning standards. So this is one of the models that I've designed for my current projects out here. I've just blurred it slightly just because of data production, but what I'm talking about, this is what is currently provided. You can see it's not available. And the research that we're doing for this project, it will enable to meet future demands. So looking into encryption side of security, looking into key management, aligning different standards, looking into threat visibility and IT-OT convergence at the same time. So a few research areas into 5G. You can see here, you can go into cloud type of aspect, data security, additive manufacturing, robotics. This huge scope going forward, and as you can have an idea out here. I've outlined few areas in my poster out here. So these are the key takeaways. What are the what is the impact of these attacks and how hackers can exploit vulnerabilities actively or passively, and why end-to-end security is essential, and the impact of risk threats and amount of vulnerabilities. So we have to be prepared for the future. So with Industry 4.0, the threat landscape is going to increase, and we have to look at every minor detail out here. Not any single, you can't say that any breach is small or any breach is, you cannot categorize it. It can move at any time from a small to a high level threat. So do not ignore anything that happens out here. So these are some of our publications and webinars. If you want to know more about what I'm working on or the projects that we're doing out here, you can just go on these active links out there. And that's where I am. And thank you very much for listening. And if you have any questions, I'll be happy to answer you. Thank you.
Thank you so much, Ms. Lubna, for such informative session. Since I have not been able to greet all of you, so Assalamu alaikum and good afternoon. This is your host, Falakna Sumeru, Assistant Manager, IEEEP. I welcome you all wholeheartedly on behalf of my team and organizers. On this occasion, I will express my thoughts about the fact that education would be much more effective if its purpose was to ensure that by the time they leave university, every boy and girl should know how much they do not know and be imbibed with the lifelong desire to know it. Following, we'll quickly move towards the sessions where we'll come to know the facts we were unaware of. I would like to request Professor Dr. Nick Harris from School of Electrical and Computer Science, University of Southampton, UK. Professor Dr. Bhavani Shankar has also gotten PhD from the same university. He's Professor of Advanced Sensor Electronics with over 250 publications in associated subject. He's founder of Pvt Company, the world's most successful vibration energy harvesting company. Sir, please, hand up to you.
Okay, so I hope you can all hear me and that you can see my screen. If you can't, then someone's going to have to tell me. So I'll just carry on anyway. Okay, so my name, as has just been said, is Professor Nick Harris, and I'm a professor in the SEMS group at Southampton, which is Sensors and Electronic Materials. The talk today is going to be on intelligent sensing technologies, examples of sensors, and the IoT for the environment. And I'm going to talk a little bit about what I mean by environment and also what I mean by of some of these sensors as well. So it was interesting to hear the previous talk because obviously the security is quite important. We've done some work on security, but I'm not going to talk about that today. We're going to talk more about some key applications. So a little bit about my background. I've been working in sensors and sensor systems for a very long time on various projects, and here's some names of some of the projects that that I have worked on, and you can see they all to do with sort of sensors in fairly sort of difficult environments really, and the one we're working on at the moment is sensors for embedding in bearings for condition monitoring, and that's obviously a very difficult environment to try and measure in. But my work in sensors has led me to wireless sensor networks and also sort of energy harvesting as well to power these things, which I'll be talking about in a couple of minutes at a time. But we also need to put some definitions in really on what we mean by the Internet of Things or the IoT. And my view is it's just devices connected to the internet, but it is developing into a form of distributed system, and we've heard about that in the previous speaker as well. And it's starting to be known as Industry 4.0. Now, Industry 4.0 isn't really defined anywhere, so it was interesting to hear that there are lots of standards and things being put forward for it now. It was really some marketing words just to get some interest in this kind of area, but the sort of definitions you can see is going from the first industrial revolution of water power and steam power through sort of development of electricity and assembly lines, a bit more computer and automation, and finally into cyber physical systems, which is sort of where we are now. But environment's something that is difficult to define as well. The environment can be many things. It can be outside in fields, and I'll be talking a little bit about environmental monitoring in that respect as well. It can be inside factories, which is typically where Internet 4 might be. Possibly inside the human body, space, and even embedded in structures, which is starting to be referred to as structronics these days. So the environment can cover many fields. So we'll look at some of those with some examples going forward. But what's common about this, in all these environments, we've got things that are common to it. We want to sense something usually, and that's fine. But how long do we want to sense it for? So if it's an agricultural sensor, you might want to sense for at least a growing season, for example. Ideally, you want to sense for a lot longer. But that introduces all kinds of problems about drift in the sensors, battery lifetime, and you don't really want to be introducing batteries into the environment if you can avoid it. How do we want to do it? Do we do a single point measurement, or do we do a multiple point measurement? There's advantages and disadvantages to both, and maybe some of those will become a bit clearer as we go forward in this. And do we process the information or the data on the sensing point or the node, or do we relay it to a central point and process it centrally? Again, there are pluses and minuses, and some of you may recognize processing on node as being a sort of an evolution of edge computing, which is currently very trendy at the moment. But whatever, it implies a systems approach. The embedded sensor is no good on its own. There's got to be a whole system around it. And I say, think about the sound of one hand clapping, and you get the idea of the usefulness of the sensor on its own with no communication and no power. So this leads us into this sort of definition of a sort of a sensing node, if you like. And I termed it the sensor nexus, with the nexus being a sort of a meeting point of several different requirements. And so we've got the sensor itself, which is fundamental to what we want. This is why we're developing this whole system, because we want to measure something. We need to power it, And that in itself can be a problem depending on the environment you find yourself in. And there are all kinds of questions there you might want to ask yourself. How long does it need to last, this power supply? Should it be rechargeable? Can it be wired? Makes life much easier if it can be. Do we have to harvest or scavenging energy? And if we do go down that route, we need to consider the environment that we find ourselves operating in. The sensor itself has its own requirements. Does it sense what we want? I mean, it sounds like a silly question, but you'll find in a lot of papers, particularly on wireless sensor networks, that people are sensing things because they can and not because they want to. The sensors that there's a lot of sensors exist, but there are quite a few requirements for sensors that don't exist yet. And so people tend to be using proxy sensors or inferring information from the sensors that do exist. And sensor development, as I'll hopefully show in a minute, is actually a tricky thing to do to get right. So we've got a lifetime issue with the sensors. How long do they last? How often wear out? Their accuracy, how accurate do they need to be? It's not going to be a laboratory grade sensor, but it needs to give you enough information to make the whole thing worthwhile. And then we've got a sort of a control point on here where we're going to look at how do we deal with this information. We've then got communication issues as well. Range, what's the range of this system? What's the reliability of the communication system? Does it depend on atmospherics, for example? Security, jamming, does it have to be real time? Is it going to be wired or is it going to be wireless? But either way, we've got to get information out of this sensor to the point where whoever's asked for this system can actually make use of that. And then there are all kinds of other factors as well. Cost is very important because if you're going to have a distributed sensor network, there are going to be lots of sensors, and they're going to be, you know, the cost per sensor becomes important then. Are they going to be disposable? Are they in fact going to contribute to pollution in the environment if we don't get them back? Deployment, how do we put them where they are needed? And that's quite an important problem as well. So there's a lot of issues that have to come together to make a sensor in the environment work properly and give you the information that you want. But I like to approach this from the point of view of an application rather than having technology driven, because fundamentally we're looking to solve a problem. And when you look at this, this usually comes to a value of information issue. Whoever's wanting this system wants their questions answered, but they don't really care about the nature of the solution. And there's an example here. I'm saying that if I'm tracking a target, for example, as a user, I don't care about how it's tracking the person. I just want to know where the target is. So from a user's viewpoint, it's important to define the problem at the front end, and then look for the technology that can solve your solution. Don't go the other way. Don't start with the technology and then look to solve a problem with it, because that's a compromise, and compromises don't work very well in these situations. So there are lots of problems that you can look at. Fixed area sensing is one, long-term monitoring in a fixed area as well, so fields and things like that. Monitoring a farm, as I said, perimeter of a building or inside buildings, quality of air, very, very important these days, air quality monitoring. Difficult environment sensoring, inside equipment, infrastructure, bearings, bridges, inside jet engines, very important to monitor what's going on in the jet engine and at least try and predict if it's going to fail or when. Inside the human body, instrumented hips, for example. Or perhaps you just want to deploy a network really quickly to help in emergencies, such as firefighters going into buildings wanting to know what's going on in there and where everyone is. And there's a big area emerging now of autonomous mobile networks, sometimes called manets, so swarms and things like that. But there's different approaches for all kinds of different problems going forward. So I'm going to go through 3 examples, and hopefully this will inspire some ideas and give you some idea of how we're thinking, at least. So I'm going to talk about a sensor system in industrial environments, which is going to be for monitoring a rail bearing and track condition. I'm one of the founders of a company called Perpetuum, which exploited and developed technology of doing just this. And I think it's actually installed in some trains in Pakistan now as well. But that's a worldwide reaching company now. I'll talk about that and their technology going forward. And I'll also talk about a sensor for environmental monitoring, which is actually a chloride sensor, which is measures chloride transport measurements in soil, and I'll explain why that's important as well. And then briefly, I'll talk about some work that we've just published where a sensor system was installed in some lemon farms in Pakistan, and the yield of the lemon farming has been improved as a result of this. So that's quite a important and interesting result that we get from a relatively simple system. So going back to the industrial application of trains, what's our motivation? So what happens when a bearing fails on a train? So here's a train. It's stopped on a bridge. It didn't have a choice. Its bearing seized, and it happened to not be able to go any further while it was on this bridge. The bridge happened to be made out of wood. The bearing, because it had seized, had overheated and got hot and stepped far to the bridge, and that resulted in, first of all, the bridge being destroyed, the train having issues, delays to all kinds of things, and $2 million worth of damage. And there's a link there if you want to go and read about the bad day that people had there. But in general, if you have problems on trains, usually a bearing failure on a train, it leads to late trains. It's not like you can overtake a broken down train. The loss of the assets. In certain countries, it leads to fines because you haven't delivered on your contracts. Certainly leads to unhappy customers. Can lead to potential deaths and lawsuits. So all these things are things that we'd like to avoid if possible. So a sensor to measure bearing health seems like a good idea. And how do we detect bearing health? We have to look into that, but basically we'll look for the vibration of a bearing that's starting to fail. And we can do that with an accelerometer. We need to power the system though. So going back to our nexus, we have to think about that. And the interesting thing is on goods wagons, there is no power on trains. Trains have no power. Only in passenger carriages. So you can't guarantee that there's power there. And even if there is power, it's very difficult to tap into it because it's a safety related issue. So we thought we could power it from vibration. So this is our sensor nexus again. So we've got a sensor, which is an accelerometer. And we can measure and process acceleration to understand what's going on in our bearing. We can power the bearing or the system from vibration because trains are not the smoothest things in the world. And then we will relay the information through some communication system and capture that and process it. And this is what we did. We developed a sensor system enabled by energy harvesting to allow us to predict the failure of bearings. And here you can see it fitted to a train. It's very easy to fit to the train. You just drill a hole and bolt it on, and that's it. So retrofitting this and installing it becomes relatively straightforward. It leads to reduced operational maintenance costs and improved asset utilization. Operates over a wide temperature range, and turns out that the vibration in trains is much, much higher than anyone ever thought. So there had to be quite a lot of engineering going into this to make it actually survive some of this, let alone power itself from some of these environments that it finds itself in. And lasts for over 5 years. Well, they've been going for much over 5 years now without any problem. And no train fitted with a perpetuum system has ever had a bearing failure that wasn't identified much in advance and was allowed to be swapped out. And so the sort of thing you get from this is something called a bearing health indicator. So this is an algorithm that works out when there's likely to be a bearing failure. And you can see over a period of time, so we're talking a period of months here at the bottom scale, the bearing health index is starting to rise, which implies that the bearing is not doing too well. And then at some point, go back, sorry, we end up changing the bearing before it's failed. And then you can see that the new bearing is nice and smooth. And here's the damage that we can find in the bearing. So this allows us to program maintenance, and it avoids the issues of trains breaking down in the middle of the track and all the other issues that are associated with that. So you can plan your maintenance because you've got several months to plan this maintenance, having seen this index starting to rise. We also discovered that not only can we monitor the bearings, but we can also monitor the track with the same sensors. And certainly in the UK and probably many other countries as well, we've got this strange system whereby the track is owned by separate company to the train operating companies, and the trains are owned by the train operating company, and they effectively lease access to the track. But these trains traveling over the rail can actually monitor the track as well, because you've got a whole load of distributed sensors going over your rail network every day. And for example, if you get a spike on your accelerometer at a fixed point geographically, then that's likely to be systematic of the track rather than the train going over it. So you can actually create a map of where there might be train issues. Now, certainly in the UK, this introduced some issues with responsibility because people don't like spending money on the maintenance of tracks because it costs money, and no one wanted to be responsible for the damage. Now, the main cause of damage on tracks is out of round wheels, so wheels that are slightly out of not round anymore. As they go around, they sort of act as a hammer, and they hammer the track, and eventually that leads to fatigue and track failure. And the question is, who's responsible? The track company or the train operator for this fault? Now, obviously, the track company is responsible for repairing the fault, but should they be responsible for paying for it if it's the train operator whose lack of maintenance on his wheels has caused the problem in the first place? So this led to a lot of issues with actually installing these systems, and political issues, I suppose you could call it. But now it's actually worked out to be very successful for all involved. Everyone gets to save money on it. And the same idea is now being used for other transport modalities. For example, sort of potholes in roads can be detected by, for example, buses fitted with accelerometers and GPS. So again, when they hit a bump, they can relay that position, and you can get early warning or earlier warning of where your holes in your roads might be. So that's quite a useful thing. So here's the sort of information that comes back. This is a map of part of the UK, and this is a section of railway line which the trains that have sensors on are running up and down all day, every day. And there are 4 tracks in this particular piece of railway, and they're shown here as track 1, track 2, track 3, and track 4. And you can see the quality of the track in terms of the acceleration data that comes from the trains going over here. This one's perfectly fine. This one's perfectly fine, and this one is starting to have an issue because we've got a big red area here, so there's likely to be either a crack in that rail or a bit of subsidence or something going on. But at least we can see that early, and then again plan the maintenance with the minimum disruption. So that's a very useful indication of a successful system. So my second example, which will look at environmental monitoring in terms of agriculture. I'll just set the scene for that because key facts are quite interesting. I like to have the context and look at the application. So on a global scale, the population will grow to 9.6 billion by 2050. And here's a graph showing the sort of average prediction of population growth. New estimates indicate that we may be on the sort of lower track, but even so, it's still going to grow significantly in the next few years. And therefore, food production, and not including food used to create biofuels, so corn for ethanol. So food production must increase by 70% by 2050 to allow this to happen. This is a big number. There's a lot of people interested in this. But we've also got this other perfect storm, that the land available for agriculture is reducing. We have more urbanization, but we have other issues as well. For example, pollution of land. So 20% of the world's irrigated land is actually degraded by salt. And salt is not good because salt doesn't allow crops to actually grow. And this is an area the size of France, which is pretty big by anyone's standards, really. And it's increasing every year. And the numbers drive politicians, $27 billion a year in lost crops per year. Now, we don't want to be losing this when we need to be increasing it. And particularly in Australia and places like that, it's called the White Death. And this is salt encrusting on the surface. And obviously nothing is going to grow here for a long time. So the main reason for this is believed to be due to overuse of water and unsympathetic farming practices. And where does this water get used? Well, it's used in irrigation. And there's some quite frightening facts here as well. 70% of all the global freshwater withdrawals are used for agriculture. Irrigated agriculture produces 40% of the world's food from only 20% of the agricultural land. So this is good. You know, we're getting, this is a really good thing. So irrigation produces good results, extra yield and everything, but we're using too much of the water. Just having a look. Oh, okay, fine. In case it all gone horribly wrong, but we seem to be good. And I've done a lot of work in Australia, and irrigation uses 80% of Australia's water resources. 80% of Australia's water is used in irrigation and produces 30% of the nation's agricultural production from only 0.5% of the nation's agricultural land. So there's a lot of scope for increasing in Australia, certainly, the amount of irrigation that happens. But Australia has this problem with salt issues. And then there are other things which strike me as being a bit mad, really. 80% of California's water is used for irrigation and accounts for only 2% of California's GDP. And a lot of this is because it's a desert and they're growing crops that need a lot of water, such as oranges, which is okay if there's plenty of water. But I think, as we all are starting to hear now, California has a lot of problems, and they really should be doing something about it and not using more water. But anyway, that's what we got. Bottom line is, if we are going to increase food production to 70% or more, we are going to exceed our current water supply. We haven't got enough water to do it if we carry on the way we are. And another example, in China, small rice farms are moving from 3 crops per year to 2 crops per year as employment moves to cities. China is an interesting case. They're moving people into cities from urban areas, and a lot of it is sustenance farming that was done there. And so we're instantly losing a significant amount of crop production in China because of this increasing urbanization, not necessarily because we've lost the land, but because the labor that grow the crops is actually working in the cities now. So therefore, something like sensors and the IoT and in the field of precision agriculture will be a vital system going forward. So this can really, really help the world's problems going forward. So the future may well turn out to be something like this, with vertical farming, using the tops of buildings. Certainly in the UK, someone calculated if we used the tops of all our supermarkets and warehouses to grow non-arable crops, we would double the amount of land available for crop growth, and would also shorten the supply chain remarkably, since it's been growing on top of the shop. So there's all kinds of novel and interesting ideas, and all these, obviously, because they're a bit unnatural, require some technology to keep them viable. But in the environment in general, there are many things that could be monitored at different stakeholders and at different scales. So here's sort of a picture of the environment, and you can see all kinds of things that will lead to pollution and issues and stuff. Fertilizer, which is a good thing in fields, is a bad thing when it ends up in rivers because it leads to algae blooms and dead fish. So we have to be aware of the scale of our issues. Fertilizing at one point is a good thing, leads to pollution in other areas if everyone's doing it out of control. So we developed a chloride sensor to monitor the movement of water through the environment, because we could inject some chloride and track it. And so the sensor development from this, I won't go into too much detail on it, but just to show you that sensor development is actually quite a hard thing to do. So we wanted a low-cost chloride sensor for salt measurement, so we could distribute it across land and work out what's going on, so we could inform land use change for politicians. So the sensor needs to be long life, last at least a growing season, ideally more. Needs to be low cost because there's going to be lots of them distributed around. It needs to be accurate enough, and it needs to be low power. So they're the main requirements for it. We chose to use an electrochemical reaction, and I won't go into the chemistry of this too much, but suffice to say that a voltage is generated by a surface with that's been coated with silver chloride, which changes by 59 millivolts per decade change in the chloride concentration. So every time the chloride changes, we get a voltage out that changes. But we have to measure that against something because it's just a potential, and we have to have a reference electrode, and this is where the real problems lie. And I'll talk about the reference electrode in a minute as well. So we used a thick film process. This is a printing process, the same technique that's used to make t-shirts. Multiple layers are built up to create a structure, and the process consists of printing, drying, and firing. So we have a ceramic, or some cases a metal, but this is a ceramic substrate, and then we can print our layers on top of it. So we printed a silver conductor to allow us to connect to the sensor. We print down an isolating layer, and this circle here is where our sensor is going to be, and then we add our silver chloride layer on top of that, which is going to be generating our potential. So you can see that we end up with a little sensing area on our sensor, and we can solder to this point here, and here's a sort of a picture of one. Size of this, we're talking probably about 30 millimeters, 3 centimeters long, 5 millimeters wide. So it's a small thing, and they're dead easy to make, and we can print loads of them. It's low cost, robust, and it's self-generating because it's generating its own potential from the pollution that it's trying to measure, which in itself raises some interesting questions. And we may compare this against a reference electrode, and this gives us a fixed potential relative to a known concentration. So we basically have to have our electrode surrounded by a known concentration of salt, and that gives us a fixed reference. And then we can compare the salt content of the soil with the known potential of the known concentration of salt here. And again, we've managed that with the thick film as well, and we've printed some extra layers. We put a porous glass layer down, which we developed, filled that with potassium chloride solution, or silver chloride solution in this case, copped it off with some conducting polymer to keep it in, and that made us a nice reference electrode. Now, did it work? So, yep, here we are. We've got 7 sensors being measured against changing chloride concentration, and you can see we've got this wonderful straight line, and they're all matched to each other. So this is great. Straight out of the packet, these things work really nicely. And this is the potential they generate, which is a nice number. We're talking millivolts here, so a couple of 100 millivolts or so. And then if you match that against the chloride concentration in the environment that we're interested in, this is 10 milligrams is about where drinking water would be. And this is what chloride sensitive plants can deal with, and this is what tolerant plants can deal with. So we're operating this range. So the sensor's operating in a really good range for agriculture. So we've made a sensor that works really well. It's robust, it's low power, self-generating, and is reasonably accurate. But it took a long time to get there. Can it provide useful data? So we designed a sort of a logging system based on a system from Libelium. It's a bit like Arduino, I suppose, but a little bit more advanced, called a WASP mode. And we added in a power supply. In this case, we just ran it off a battery because we can get these sensors back. And then we really relayed information through an 802.15.4 shortwave radio system to a receiver on the laptop nearby in this case. But we had multiple sensors connected into this one node here through a multiplexer and amplifier. Bit of self-test because we need to be sure that some of these things are working. And then we could log to an SD card and we can stream by radio as well. So we tried that out in a experiment in the greenhouse in Australia. So this is at University of Western Australia. They have some big greenhouses, and we put our sensors into a known environment, in this case a sandy soil, and put them at different depths. Put some salty solution in here and then let it dry out over a period of time just to show what was going on. And this is the last few days of our 2-week experiment. And you can see a diurnal variation straight away in terms of the concentration of salt in the moisture that we're measuring against time. So you can see the 24-hour period, which in itself is interesting because no one had seen this before. And you can see that the sensors that were buried at about 1 centimeter or 2 centimeter depth from the surface were showing this variation. The sensor buried at 20 centimeters was showing very little variation across the 2 weeks. And at this point here, when we're starting to get high concentrations of salt, we were starting to see salt encrusting on the surface as well. But what's important about this is that it's important what time of day you make a measurement, and it's important at where you make the measurement, because a distance of 20 centimeters means that you could measure this and say there's no problem, whereas near the surface, you're seeing big problems. What you're really interested in is what is the salt concentration that the roots of the plants are seeing. And agricultural plants like corn and things actually have very shallow roots, so are likely to be seeing this kind of environment rather than this, hence the problem. So it tells us it takes a lot of effort to develop a usable sensor. Distributed sensors can allow much finer temporal and spatial results because you've got more of them. Normally, to find out the salt in your soil, you can actually take a sample and dissolve it and put it into a measuring system, and that wouldn't tell you anything about the distribution of the salt within that soil, just the overall concentration. And you can only take one measurement because you've dug that point up at that point. You can't go back and measure it again. So now, for the first time, we can see that the salt concentrations vary by an order of magnitude, at least in 24-hour period. So this is telling you that the position of your sensor is vital and that the time of the measurement is vital. And this is telling us a lot more about the environment we didn't know before. And what it's sort of telling you is that sometimes it might be better off having no data rather than measuring stuff and assuming that that is representative of the real environment you're in. So I found that quite interesting, really. So in this case, traditional grab sampling, where you take a sample and take it back to the laboratory at a single point every 3 months, will give you a completely different, in this case, wrong answer to a distributed sensor network with a real-time IoT link. So again, it's important to get the right answer by asking the right questions. Data is as only good as, as your interpretation of it and understanding what it really means. So there's a picture of a typical environment showing salt crystallization in Western Australia. So this is the salt. This is a freshwater river, believe it or not. But this is salt that's coming through from underground, being driven by rising water tables because people are digging out indigenous trees which have long, deep roots. So these would, the long, deep roots, tap roots, would actually take out a lot of water from the environment and transpire it into the atmosphere and keep the water table down. When you take those away, the water table is allowed to rise, and that brings salt with it. And that's one of the driving factors in this case. So it's maybe counterintuitive if you think about it, but that's what happens. So just to finish off then, I just want to talk about some of the latest results we recently published. So we did an experiment, or a colleague of mine did an experiment on a lemon farm in Pakistan in Gadap, if you're familiar with the area. I've never been there, so I don't know what it's like really. And they developed an internet-connected decision support system. So we were measuring real-time soil moisture data from a local node, so a sensor that was put into the field effectively, looks like this. And that would measure the soil moisture content and relay that back to a central system, which would then send that information to an app to help the farmer decide whether or not he should irrigate or not. And the irrigation process was slightly complicated here because farmers only had access to water at certain predetermined times within a 2-week period. So most people would then say, well, actually, if I've only got water for 1 hour in a 2-week period, I will water for an hour in that 2-week period just to be safe. But it turns out that you don't need to do that. And even taking that into account, this system allowed 35% more lemons per tree from actually 50% less water. If we get 50% less water in irrigation systems, then that means we can double the amount of land under irrigation and not use any more water. And that gets us closer to this issue of getting 70% more food for the same amount of water supply that we need in the next 50 years or so. So this is an early indication that technology can help us to do this. So there's some numbers here in perspective. If you scaled this up across Pakistan's lemon production, you would save 646 megaliters of water, which is a lot. And not only that, you would generate an extra $14 million of revenue for that crop. So it's a win-win situation. And the only issue is how expensive is it to actually install this system? And it turns out to be not very expensive at all. And the system is available for purchase. If any of you have any lemon farms that you want to instrument from a local company to you. And there's the web page if you want to go and check that out. Or you can look the paper up and get some more detail from that. So in conclusion then, embedded IoT sensors of any description should not just be considered as sensors, but as holistic information gathering systems. I've talked about some of the issues, and the previous speaker that I heard also talked about a very important issue in terms of security for these systems as well. So it's not a simple way of doing things. The application defines the approach, in my view. You need to define your problem and then define your system. And that will give you all kinds of links onto other aspects, such as the lifetime, the cost, the robustness, and what communication system that you may need to use. But the sensor is the vital part of this. The rest of the system supports the sensor in achieving the mission, but the mission needs to be well defined. And that will bring me to the end of my presentation, and I hope you found that interesting. And maybe we can take questions. I'm not sure how the system works, but that's me done.
Thank you so much, Mr. Nick Harris. Do we have any questions? If you do, raise your hand. We don't? Okay. Thank you so much, sir, for taking time out of your busy schedule and for being part of this workshop.
Oh, I hope you find it interesting, and thank you for having me.
That was quite interesting.
Thank you, Nick. Thank you very much. Nice presentation. I think our researchers got good insight what Southampton ECAS people are doing and all that innovation research. I think some of them got motivation to do masters from here and then maybe PhD from Southampton. Thank you once again.
We'll be very pleased to have them. Okay, bye-bye.
Girls and boys, the goal of education is not to increase the amount of knowledge, but to create the possibilities for a child to invent and discover, to create men who are capable of doing new things. Ladies
Vice Chairman NEPRA, and he's a member since, and more, he's our alumni. So he's with us as a chief guest. Please give a warm welcome. And we have got CSR consultant, Ms. Huma Zafar. She's corporate social responsibility consultant, NEPRA. And whatever show this session we are having, that is one of the efforts of Mr. Irfan Saab, who has been associated with Mehran University since last 32 years. Every year when he used to be in Siemens used to come here and conduct, recruitment test at Mehran. And when he used to come to Hyderabad or in Karachi, many IEEE seminars, he mentioned that Mehran graduates, they are really, jewel in crown because of their performance. These are words he used to say. We are grateful to Irfan Saab and Huma Zafar. I remember Irfan Saab was attending one of our board meeting. He's a member board of trustees, one of the endowment fund. And from there we were visiting to our labs, and then there was a phone call from madam, and they were discussing about half an hour about this project, and we were just, other guests were there from Islamabad, and we were actually having, conducting some interview of the progress of our some PhD students. So it's really, again, please have a good clapping, warm welcome to our guests. So I think let's hear more about Irfan Saab for bringing this very novel aspects of corporate social responsibility. That is the need of time. And since yesterday, we have been talking about triple helix, and there's a university, academia, government, and now when you heard Vice Chancellor yesterday, he said community and society, that is more important. And today we are realizing that people say dream never come true, but we must say dream always come true. So this dream we saw a year ago, but now is coming to reality. So now I invite Irfan Saab to give his information about this corporate value. Thank you.
I think this will be much better. I can see that. Yeah. Thank you, Dr. Saab. Thank you for your kind words. Mehran, when I want some inspiration, I come to Mehran University. And bright-eyed students, smiling faces, and they do good research work as well. For example, this mask is a result of research at Mehran University, and it's known worldwide, NanoClo. Then we were talking just now with Dr. Mahar, who has invented very cheap, very nice arsenic filters. There's a lot of arsenic in Sindh's water, groundwater, and we need such type of filters. Oh, sorry. I'm not used to that. I'm used to collar mic. So okay, let me keep it here so that we are free. So now let's come to the topic straight away. The new CSR. We are calling this new CSR because we have stretched the definition of CSR. I wanted, Professor Saab is here. That's great to have you here, Professor Saab. So we call it new CSR because we have stretched the definition, and we can always stretch the definition. We can even coin our own definition per our requirement for anything, for energy audit, for whatever you can think. If you think that whatever West has given us doesn't match with our requirements, you can coin your own definition as per your requirement. But then you have to stick to that requirement, okay? So this is what we did, the new CSR. And what we want to do is to create value for the stakeholders. So who are the stakeholders you will see as we proceed along. But I think in this case, we all are stakeholders. Everybody is one of, especially the engineers. They are the stakeholders for this project. Just to give you a short background, I think I'll talk in Urdu and English. I know a little bit of Sindhi, might be I'd use that. I'm domiciled in KPK, Professor Saab. But I used to speak very good Pashto, but later on I learned German. So ये दो जुबानें एक साथ नहीं रह सकती एक म्यान में. So I had to divorce one of them, and that was unfortunately Pashto. I still remember my German. So, oh, sorry, I was, yeah, back to this one. So here you see Google 2004. Pakistan is in the dark, India is shining. If you see Google 2016, you will see the same picture. We didn't do much as far as energy is concerned. We didn't do much during the past, so many years. But suddenly we have excess power, surplus power, but we don't have transmission systems, transmission and distribution system. So still the picture remains the same. So there's no load shedding. अगर आप कल हैदराबाद में होते तो आप कहते हैं हाँ ये लोड शेडिंग हो सकती है. कराची में भी 90% feeders were not there after the rain. लेकिन ये ऐसा है नहीं. इसकी जो main reason is कि per capita electricity consumption in Pakistan is 1/5 of world average. हम इतनी बिजली इस्तेमाल ही नहीं करते जो हमें करनी है. हमारे कितने सारे विलेजेस जो हैं सिंध में 15,000 विलेजेस नीड इलेक्ट्रिफिकेशन. उनके पास है ही नहीं वहाँ बिजली. दैट्स एन अपॉर्चुनिटी. और दूसरा जो मसला है वो ये है कि वेस्टेज हमारी बहुत ज़्यादा है. Our wastage 3 times the world average. इस वर्ल्ड में सारे मुल्क शामिल हैं, सोमालिया और साउथ अफ्रीकन रिपब्लिक और छोटे छोटे मुल्क सब शामिल हैं. और हमारी वेस्टेज इज 3 times the world average. So this is what we thought that this could be a CSR project, that we stop the wastage, this wastage, and that we should do by using local expertise, local, whatever we have developed, and not as a corporate social responsibility, we have given it to the businesses that 50,000 of our engineers are jobless, and they should create jobs for those engineers. And they should, and this one is a big project, increasing efficiency, reducing wastage. And this is what the CSR project is actually. And as we go along, you will see that this is how we have defined it. So I don't want to, if you see here, this is the load, energy flow diagram of Pakistan done by NRF Engineering. This is 2019 diagram. In 2015, we had another one. We produced this for Pakistan Business Council. So the data is authentic. It's data from the government. As far as it can be authentic, it is. So this is the primary energy. And 89% of the primary energy, which includes nuclear, solar, wind, hydro, everything, only 11% is changed into useful energy. Less are losses in Pakistan. From primary to useful energy, 89% are losses. And out of these two, I have shown here, T&D losses, 22%. That's what NEPRA says. Actually, the losses are much more than this. They're close to 30%. If you see the government data and convert this, you'll find that losses are more than 30%. I've written 22 because in the State of Industry report, NEPRA says they are 22. The other is transport losses, which are close to 80%. $7 billion worth of petrol and fuel is imported. And you can see $6 billion of fuel is wasted. हवा में हम फूंक देते हैं. सिर्फ एंट्रोपी इंक्रीज कर रहे हैं दुनिया की. एंट्रोपी अगर आप इसको सलीस इंग्लिश में लें तो इसका मतलब है डिसऑर्डर, और सलीस उर्दू में इसका मतलब है फसाद। तो हम फसाद बढ़ा रहे हैं दुनिया का, जो हमें मना किया गया है। तो वी हैव टू सी कि वी इंक्रीज आवर एफिशिएंसीज। हमारे ओवरऑल एनर्जी एफिशिएंसीज जो हैं पाकिस्तान में, दे आर मिजरेबल। अमेरिका की ये फिगर जो हमारी 11% है, अमेरिका की आप देख लें गूगल खोल के एनर्जी फ्लो डायग्राम उनका, इट्स 40%. So at least we are using the same equipment, same things. So we have to increase our efficiency to come at least to the American standards. So this is an issue. We are, sorry, I'm again. Can you go to the next slide? Yeah. Now this project, what we have started, it's limited to wind power projects. So I just wanted to show you why there is a lot of room for improvement in wind power projects. The output of wind power project is given in this formula. And there is one factor, which is CP, one parameter. And CP gives the efficiency of the wind turbine. लेकिन चूंकि फ्यूल फ्री है, हमारे पास हवा फ्री में है, तो हम इसकी एफिशिएंसी के बारे में कोई ख्याल ही नहीं करते। और चूंकि हम डिज़ाइन नहीं कर रहे अपनी विंड रिजीम के हिसाब से, सारी जो चीज़ हमें बाहर से सस्ती मिल सकती है वो हम ले आते हैं, तो उनकी एफिशिएंसी का उसमें कोई ख्याल हम नहीं कर रहे होते। तो यहाँ हमने कहा कि इसमें एफिशिएंसी वी आर लूजिंग अ लॉट इन द विंड टर्बाइंस, so we should look into that if we can improve wind turbine efficiency or wind projects efficiency as such. So this is what we want to do. और एक चीज़ मैं आपको बता दूं यहाँ, फॉर एग्जांपल विंड प्रोजेक्ट्स की एफिशिएंसी जो है वो इस पे भी एक्सटर्नल फैक्टर्स पे भी डिपेंड करती है। वन एक्सटर्नल फैक्टर इज वेक। जब विंड में टर्बुलेंस आ जाती है तो उसकी वजह से विंड टर्बाइन की एफिशिएंसी जो है वो रिड्यूस हो जाती है। अब इस वक्त जो मैंने आपको यहाँ दिखा रहा हूँ ना, ये टर्बुलेंस की पिक्चर है। सीमेंस की टर्बाइन्स हैं, ये नॉर्थ सी में कहीं लगी हुई है, और ये फवार जो उठ रही है पानी से, आप समझें इसी तरह विंड में भी इसी तरह की टर्बुलेंस आती है। आप देखिए पीछे कुछ ये टर्बाइन्स आपको नजर आ रही है छुपी हुई सी, और जो सामने वाली टर्बाइन है इसकी जो टर्बुलेंस है, विच इज कॉल्ड वेक इफेक्ट, दिस इज डिस्टर्बिंग ऑल द टर्बाइन्स बिहाइंड। तो एक तो टर्बाइन का सेल्फ वेक भी होता है, वो खुद भी अपनी टर्बुलेंस के जद में आ जाती है, और दूसरा उसका जो वेक है वो दूसरी टर्बाइन्स को भी डिस्टर्ब करता है। तो इस टर्बाइन का फिर इसका फिर इसका फिर इसका ये मिलके, तो वेक लॉसेस जो हैं दे आर बिटवीन 5 to 15%। हम एक थंब रूल के तहत 6% लेते रहे शुरू से, कि 6% वेक पे हम अपना प्रोजेक्ट कैलकुलेट करते रहे। We have not yet been able to calculate or determine the exact wake losses. तो ये जो प्रोजेक्ट है इसका ये काम भी होगा कि wake losses determine करे, self wake और other wake, and then और wind resource data को लेके ये determine करे कि हमारे losses actually हैं कितने और उनको फिर reduce कैसे किया जा सकता है। पहले तो हमें पता होना चाहिए कि हैं कितने। यार सॉरी, हाँ नीचे मैं देख रहा हूँ, लेकिन हाँ, तो ये अब आपने देख लिया कि कहाँ कहाँ लॉसेस हैं। एक तो टर्बाइन्स में लॉसेस हैं, वेक लॉसेस एक्सटर्नल फैक्टर्स हैं, इंटरनल हैं। शेयर लॉसेस हैं कि विंड जैसे आप ऊपर चले जाते हैं तो विंड के डिफरेंट लेयर्स हैं, उनकी आपस में फ्रिक्शन होती है। विंड सारी एक ब्लॉक में स्मूथ नहीं चल रही होती, इट्स डिफरेंट ब्लॉक्स एंड दे आर डिफरेंट स्पीड्स ऑफ विंड्स, so there is friction there. So you have to measure at different heights the wind speeds and dust in them, all those factors, and find out what is the friction and what are the losses. Okay? These losses are also have not been determined. I have less time, so मैं उसको skip कर गया। ठीक है, तो very good question डॉक्टर साहब के, ये shear losses जो हैं इसको भी हमने consider किया होता। अच्छा, अब ये कॉर्पोरेट सोशल रिस्पॉन्सिबिलिटी, जैसे मैं कह रहा था कि हम उसको स्ट्रेच कर लें डेफिनेशन को। हमने स्ट्रेच ज़्यादा नहीं किया इसको, हम आइंदा ज़रूरत पड़ेगी हमें अपनी रिक्वायरमेंट्स के हिसाब से हम इसको बना लेंगे। तो कॉर्पोरेट सोशल रिस्पॉन्सिबिलिटी जो है उसकी चंद एक रिक्वायरमेंट्स होती हैं कि इट शुड बी लॉन्ग टर्म प्रोजेक्ट, उसमें सिंसेरिटी इन्वॉल्व हो, मार्केट सिचुएशन को देखें, एक रिस्पॉन्सिबल चीज़ हो, एथिक्स इज़ वेरी इंपॉर्टेंट। ऑल दीज थिंग्स आर इम्पॉर्टेंट फॉर कॉर्पोरेट सोशल रिस्पॉन्सिबिलिटी। तो दिस प्रोजेक्ट इट कवर्स ऑल द एस्पेक्ट्स। अभी इस वक्त तो मैं एक्सप्लेन नहीं कर सकता, लेकिन यू कैन बी श्योर ऑफ दैट। एंड वन सच CSR activity which covers all these goals is educating and training local engineers who would help in sustainability of the energy projects by reducing dependence on foreign experts. So this is what we want to do with this project. We want to have our local engineers and they should do this part. Just to explain you okay, where we have losses and how much we can save. So this is one string of wind power project. ये wind turbine है, इसी string के साथ दूसरी भी लगी हुई है, तीसरी चौथी, they can be 9, 10, 11, whatever, how many wind you can, it depends on the size of cable you have got here and size of the wind turbine. यहाँ से 690 volts पे we generate. We raise it to 22 kV. There's a small transformer here. The collection system, turbine is at about 1,000 acres पे ये लगी हुई है turbines. एक turbine के बीच में फासला जो है 500 meters का है, half a kilometer. तो इसलिए it's a big, huge area, and there's a lot of cable link there. So there are losses in the cable as well. And then there's a step-up transformer which raises the 22 kV to 132 kV, and then we go into the public grid. Public grid की जो चीजें हैं, losses हैं, हमारे चीफ गेस्ट शेख साहब हैं यहाँ, और इन्होंने HESCO पे बड़ा काम किया है, and we would like to hear from him कि where there are a lot of losses, especially in HESCO. आप तो chairman of the board भी रहे हैं डॉक्टर साहब HESCO के, तो you know कि losses are still 28% जो हम show कर रहे हैं वहाँ, although average losses yeah, you're right, that's what I'm saying, they're much more. So, but we are still telling NEPRA that they are 28%. NEPRA is asking us to reduce them below 20. So ये losses जो है ये हमने कम करने हैं। ये ग्रिड की बात हम कभी फिर बाद में करेंगे। तो यहाँ सेविंग पोटेंशियल जो है इस पूरे 50 मेगावाट विंड पावर प्रोजेक्ट में, अगर हम ब्लेड वॉशिंग करें, मेरा ख्याल है हमारे साकिब सही साहब हमारे एक्सपर्ट हैं, he will be able to explain that part much better. With 10 gigawatt hours we can save in a 50 megawatt project per annum. Turbine condition monitoring से हम 3 gigawatt hours तक losses save कर सकते हैं. Revenue, this is big revenue. अगर आप 25 rupees per kilowatt hour जो आजकल है wind turbines का multiply करें, तो this is comes into 80-90 million rupees per project. And then electrical balance of plant about 0.5 gigawatt hours. So this is the potential. So, ये Saqib Sahab will come and explain this. This is algorithms developed by Saqib Sahab. जी, blade washing पे सर. Saqib Sahab का details है. Next presentation. He does that. तो यहाँ हम ये मुख्तलिफ algorithms हैं, इनको apply करके we can save so much money. Electrical balance of plant हम कहते हैं कि जी हमारा जो है, बल्कि पूरा ये wind complex है, इसमें we can, पहली बात तो ये है कि ये बहुत सारा काम हम यहाँ कर सकते हैं. Electrical balance of plant, this yellow part, transmission line छोटी सी जो हमें चाहिए होती है, we can do here locally, and then we can design and everything we can do. The only thing we need to import is wind turbines. और wind turbine में भी हमने ये recommend किया था कि ये जो towers हैं, ये अगर आप concrete के बनाएं जो सारी दुनिया में बन रहे हैं, 60% of the wind turbines have concrete towers all over the world. So we have got local expertise, we have got material, everything is available. Why shouldn't we make them here? If we do that, तो हमारी जो local value addition होगी, this will be around 70%. इसका मतलब ये है कि 70% आप रुपी में प्रोजेक्ट करेंगे और सिर्फ नेसल इक्विपमेंट ब्लेड्स वगैरह के लिए आपको इनको इंपोर्ट करना पड़ेगा, कुछ इलेक्ट्रॉनिक्स पार्ट्स हैं, कन्वर्टर्स वगैरह. सो वी कैन लेटर ऑन वी कैन थिंक ऑफ मैन्युफैक्चरिंग देम आल्सो हियर. तो ये हम कर पाएंगे. तो इस प्रोजेक्ट में हम ये भी देखेंगे कि हम किस तरह लोकल वैल्यू एडिशन को इंक्रीज कर सकते हैं. दिस वन पार्ट. तो विंड हमारे पास पोटेंशियल बहुत है, 400,000 megawatts, that is 400 gigawatts. लेकिन यूटिलाइज वी हैव जस्ट 1.3 gigawatts. Synth potential is 100,000 megawatts. Alone Gharo corridor is 60,000 megawatts. Then we have 3-4 other corridors which we have yet to explore. We are exploring a few. So 100,000 megawatt is firm potential. तो इसको हमने यूटिलाइज करना. आइंदा गवर्नमेंट ने कहा हुआ है कि जी 30% by 2030 30% will be renewables. 30% renewables अगर है उस वक्त तो कॉस्ट आएगी उसकी about $200 billion for generation, transmission, and distribution. So we don't have these dollars. Unless and until we increase the local value addition, we do it in rupees, we won't be able to achieve that target. So that's necessary that we do it locally. अच्छा, दूसरी चीज ये है कि अगर हम कंक्रीट टावर्स इस्तेमाल करते हैं तो हम लेवलाइज कॉस्ट ऑफ इलेक्ट्रिसिटी को हाफ कर देंगे, क्योंकि द ओनली थिंग लिमिटिंग अस इज द टावर लाइफ. स्टील की टावर लाइफ जो है दैट इज 20 years एंड कंक्रीट की टावर लाइफ इज 40 years. तो the tariff or levelized cost of electricity is the cost, sum of the cost and sum of the kilowatt hours over the economic lifetime of the project. Economic lifetime आप double कर देंगे तो tariff आधा हो जाएगा. Very straightforward. जो स्टील की लिमिटेड लाइफ है 20 years की, जो हमारा प्रोजेक्ट टर्म भी होता है, वो वजह यह है कि वाइब्रेशंस होती हैं, उसकी वजह से फटीग आ जाती है स्टील. अगर इससे ज़्यादा आप यूज़ करेंगे तो कोई गारंटी नहीं करेगा. टर्बाइन किसी वक्त भी गिर सकती है, उससे पहले भी गिर सकती है. अभी पिछले दिनों जिम्पीर में एक टर्बाइन गिरी है. तो हम ये चाहते हैं कि पॉलिसी जो है गवर्नमेंट लेके आए इस तरह की कि इन चीज़ों को सपोर्ट मिले. शेख साहब यहाँ हैं. हम चाहेंगे कि जो रिन्यूएबल एनर्जी है उसको दे शुड कंसिडर एज अ डिस्ट्रीब्यूटेड जनरेशन रिसोर्स विच शुड बी हैंडल लोकली बाय द प्रोविंसेस एंड नॉट बाय द फेडरल एजेंसीज. तो ये पॉलिसी में एक शिफ्ट होना है हमारा छोटा सा. और अगर प्रोविंसेस रिस्पॉन्सिबल हो,
we give this to private sector. We just start developing the transmission line. It's not that I'm saying. We are facing it. The transmission is not there. The grid system is not there. Why don't you recommend the government to give the transmission sector to some of the town sector, especially the wind side, to the private sector? We are not thinking of it. You are asking the value addition for the Pakistan project.
Okay, so Taisa, just 1 minute and then I'll finish and we can perhaps take your question. दूसरा ये है कि WPPs will make more sense if local value addition can be maximized to create jobs in Pakistan and not imported to create jobs elsewhere. हम यार विंड टर्बाइन्स नहीं बना सकते. लोग कहते हैं विंड टर्बाइन होती क्या है, खंबा लगा के पखा लगाना होता है. हाँ, you can't make that. और यहाँ तो इतने लोग हैं यहाँ और इतने experts बैठे हुए हैं. We should start doing that. At least start with the concrete towers. So if we don't do that, अगर हम गालिब के इस शेर अपनी हस्ती से हो जो कुछ हो, आ गई घर नहीं गफलती से ही. This is what he wanted 200 years ago from us. ये नहीं करेंगे तो फिर हमारा हाल वही रहेगा कि बल्ब में हम कैंडल लाइट जला रहे होंगे. And Karachi will be city of candle lights. Even Hyderabad. लेकिन मैंने वो चाइनीज में थैंक कर दिया है, शेशे. Okay. So coming to Plaza, it's a big subject. Okay, why we are not doing that? तो हाँ, आप बिल्कुल सही फरमा रहे हैं कि हमें करना चाहिए. हाँ, हाँ नहीं लगनी चाहिए. बिल्कुल बिल्कुल. हाँ ठीक कह रहे हैं चौथाई साहब आप. You are right about that. Thank you. we can have a private discussion later on. Otherwise, it will take very long if we start that.
Thank you so much.
Thank you.
Thank you so much, Engineer Irfan. That was quite interesting presentation. So was the topic corporate social responsibility. I really liked it and I want to get into it after the workshop. At this moment, I would like to welcome our worthy Vice Chancellor, Professor Dr. Mohammad Aslam Uqaili. Yep, that's right. Before inviting the next gentleman, I will want to share with the court, aim for success, not perfection. Never give up your right to be wrong, because then you'll lose the ability to learn new things and move forward with your life. Remember that fear always lurks behind perfectionism. The person that I'm going to call has worked on various instincts as navigator, sonar officer, and weapons officer on board Pakistan Navy submarines, while algorithm Pvt implements and services asset performance monitoring software and condition monitoring algorithms used in breakdown predictions for the wind industry in Pakistan and abroad. While algorithm continues to implement and service its own web-based industry-specific ERPs for apparel manufacturing and export sector in Bangladesh and Pakistan. Mr. Saqib Saeed, CEO Algorithms Pvt Ltd, where he will be sharing regarding wind power plants, asset and turbine condition monitoring. Please, sir, I would be thankful if you could come on the stage and share with us the topic that I just said. Thank you.
Hi, Assalamu alaikum. Can you all hear me very well? It's good to be back at Mehran. I was here about 3 months ago, thanks to Dr. Saab. And he was just floating an idea, why don't you, give data to our students so that they can do some research? And it sounded a little odd to me. Okay, so, and here today, it's a reality actually. So my organization will be placing a server very soon at a wind power plant in Jampir. We've ordered the hardware and everything, and we're going to be streaming the data here in Mehran, live from a wind power plant, probably within the next 3 weeks. And we are doing this pro bono, and with the cooperation of Mr. Irfan. He's worked very hard for it. It's unprecedented that a capitalist like us, I'm not an academic, that we will part away with our data. So I don't know, he convinced me to do it pro bono. He convinced Mr. Adnan Tapal, who is the owner of this plant. He said, okay, yeah, sure, you can place the server in my plant. And if you want to even ask them the simplest of question, and I'm sure NEPRA would be a witness to that, they would never utter a single word unless a lawyer present. And here we are. They are sending out streams and streams of live data. They are ready to do it. And I can't thank enough Mr. Irfan. I don't know, sir, how you did it. And I can't thank enough Dr. Chaudhary. And I don't know what you did with Mr. Adnan Tapal. So the data is coming over here, and you will have a live taste of what a power plant looks like. Well, in fact, you are already having a taste of that already over here. Iski resolution ka issue chal raha hai. Isko aap kam resolution pe karte ho. So that's a live power plant actually you're watching. And I'll just, I don't like PowerPoints very much. So I haven't prepared any, but I'll take you through what a live power plant looks like. And when the data starts coming here in Mehran University, I want to inspire the engineers what they can do with that data. And it is absolutely very, very powerful. You can do a lot of things with that. So here, for example, till they adjust the resolution, because we are only watching half the screen right now. These are 31 turbines. So this is a plant, I'll not name it. It is about 130 kilometers from here in Pakistan. And my organization has placed about 14 servers in 14 different plants. 8 of them are in Pakistan and 6 of them are in Sweden. And that's what we do. Our customers are not universities. So this is the first time. I'm also very nervous. Our customers are paying customers. We stream this service to them and they pay us and we take care of them. So here are 31 turbines that you can watch. And I can bring my mouse onto the turbine and you'll immediately see how much power it is producing, what's the wind speed. And then there are some color codes here that you can see. So green would mean everything is okay, you don't need to worry about. Red would mean that this turbine has tripped because of some reason. Black would mean it's not giving you any data right now, and so on and so forth. And then on the gauges over here, okay, can you close this picture on the top right of the screen, please? Yeah. I'm not the most important feature of the software, really. Okay, so you see these gauges. So one of them says expected energy. So this is like about 500,000 calculations that are taking place every day to get you this information, just this 1 meter, which is saying expected energy. And there is a wonderful standard of IEEE which teaches us how to do that, which is IEC 61400-12-2, as well as -1. So I'm actually going to keep piling the assignments onto the engineers, because if they get this data and if they have the standards, then nothing is stopping them from building this thing up, which you are watching right now. So expected energy is a concept as defined by IEC, which tells us the potential of this plant, how much energy this plant should be producing right now. Because we understand this is dependent on wind. So wind will be, sometime there will be gusts, the velocity will increase, decrease. And on a large power plant strewn over an area of 9 kilometers, the wind speed is hardly ever likely to be uniform across all the turbines. So you take the data from the sensors, like we had a previous seminar from Southampton. The sensors are telling you what is the wind every second on every turbine, and then you mathematically treat it, you sum it all up and show it on there on the meter live. So it is saying, given the wind 130 kilometers from where we are right now, this plant should be producing 16.77 megawatt. By the way, this is a 50 megawatt plant. And what it is actually producing, this is another way, other sensors. So there are energy meters at the foot of every turbine. So we are picking up the data from there. And then 8 or 9 turbines are grouped together, as Mr. Irfan had just shown us. And those groups are called loops. And those loop cables, they arrive at a substation where you have more energy meters. So if you take the difference between how much energy was produced at the foot of the turbine and what was received at the substation, you can immediately calculate how much of energy was lost in the cables and how much of it was lost in the step-up transformers at the foot of the turbine. Then you step it up yet again, goes into the power transformers. You want to bring it up to 132 kV in this case. And that's when you connect to the grid. So there is another couple of meters, the main meters and the backup meters, where you are doing this grid interconnection. So this software is going to pick up the data from those meters as well. And again, nothing magical. There is another international standard called IEC 61850 that gives you the protocols, how to connect with the BOP SCADAs, with the RTUs, and how to interpret the data which is coming out, which tags mean what. So that's all we are doing as a company. We are picking up the data from the meters, from the foot of the turbine, and very simply, we are showing you live how much this plant is producing, ought to be producing, which is the expected energy, how much it is actually producing, and what's the wind right now, the average wind speed at the park, which is 7.8 meters per second at the moment, and what direction the wind has. So that's coming from another sensor, which are the wind vanes. Simple, very, very logical. And then some temperature sensors are picking up the ambient temperature, pretty hot. And then there is 100.7 right in front of you. That's the power curve efficiency. So there again, there is an international standard, IEC 61400, 26-1, 26-2, and they tell you how to create the measure the efficiency of a power curve, and 12-2 as well. So again, we're not really inventing anything here. The knowledge is out there. The biggest problem probably in academia would be getting hold of the best possible real operational data. And I think that's a limitation that Dr. Saab and Mr. Irfan have already removed. So there's really nothing stopping you all from making something similar on your own. And I could probably imagine a dozen or more theses of the PhDs or MPhils coming right out of each standard out here. Let's go further. There are two more meters that you see. One was the power curve efficiency. I told you this is picked up from 12-2 IEC. The other one is blade efficiency. So this one is a, sir, this one is a patent. We applied for a patent in Sweden for that already. This one measures the loss of aerodynamic force on the blade, either because of accumulation of snow, icing in the colder climates, and in climates like ours, accumulation of dust on the leading edges of the blade, sir. So that's one algorithm that we as a company developed. We have filed its patent, and it works for dust as well as icing. So right now it's giving you a very nice number, 99.2. Can any one of you guess why it is 99.2? If you would have seen 3 days ago, this was at 88%. Rainfall, yeah, there we are. So let me go a little deeper into this. This was your question also about washing, sir. Yeah. Yeah, I'm a little taller for this step. I don't need it. Okay. I'm not used to using the mouse. Yeah. So we're going to watch 4 years of dust and 4 years of rain right now. I suggest you look at the graph, which is the light blue one, not the top one. So if you see the light blue graph, these are mountains and valleys. And so that means the efficiency is going up and coming down and going up and coming down, depending on how much of the time has elapsed since the last rainfall. So there we are, a bit of good rain, and we rise up to almost 100%. And if it doesn't rain, then our company developed a method. We again got it patented. And we also got it, the method validated from TÜV, Germany, 3 months ago. So this is a commercial service that we provide for washing the turbine. So what we have done is that we have created a ground-based container-mounted water jet, which rises up to 100 meters. The fountain goes up, decimates, atomizes, and we park it upwind of the turbine. So the wind kind of carries the mist into a moving turbine, and the turbine washes itself. So that's the method. We wanted it to be least intrusive. We didn't want to have a method that will, in which we will come into collision with the O&M service providers. We've got a big hold on the project owners. So we stay away from the turbine 20-25 meters, just throw a water jet and the turbine washes itself off. So that's something that we've done. We've got a sister concern, wholly owned subsidiary of ours. We call it Jet Wash. So that's the one which does this. I'll go back to the dashboard. Now, one of the major things that was our objective was the subject of production losses. And I think that was the theme of Mr. Irfan. And I think he's pretty right. And some of the figures that he presented are within the ballpark. So a 50 megawatt plant, if it is unfortunate to be located in Champir, tends to lose about 7 to 11% because of the dust accumulation. That's a huge number, huge number. We tend to rely on foreign expertise a lot. So most of the wind resource assessment studies and the target numbers of these power plants were made by consulting firms abroad. But they never factored the dust coefficient in. And so most of the plants we see struggling to achieve their P50s, their target productions. We'll cover that also in the software. So that's one very big source of loss. Then if you see this donut on the bottom right of the screen, this is today's loss. So it's not just calculating losses, it is calculating them in real time. So for example, it is calculating how much I've lost because of the dust accumulation, how much electricity has been consumed within the plant, how much of the energy was lost because the turbine shut down, for example, for some time, for any reason, whether it was a planned maintenance or this was an alarm. Some parameter went out of the limits and the turbine shut down and it needs to be repaired so that it can come online again. So those are the sources of losses. And then of course, in the initial years, I think the gentleman, Chuktai Saab, is that correct, sir? So you had a lament with the transmission lines, sir. So I assure you that's not a problem anymore, sir. But we did have a big problem, and HASCO did a lot of work back in 2017 and 18, and beginning in the 16. So I think, sir, evacuation is least of our worries. What had been the big worry were the curtailments, and they were not because of evacuation. They were more because of the tariff issues, which I believe have just been resolved. And hopefully that's no more an issue. And the record is out there, so I'll just click and you will see, sir, there is absolutely no transmission line problem on this plant, sir, and many others that my servers are placed at, sir. Okay, so we've seen the power curve efficiency, we've seen the dust calculation, how much losses because of downtimes and so on. And then there is another very interesting element that we introduced, and Irfan Saab didn't talk about it. If you see the green line on the bottom left, which is going forward in the future, on the bottom left, there is a green staircase which is moving out into the future. Because the blue line and the red line, they are showing you current right now, if you look at the time. So this future is telling us how much energy this plant is likely to produce over the next 8 or 10 hours. Now we go on a very, very long length to get this. So we send out the data from our servers. And sir, I think this is part of our Mehran program as well. So we will send out this operational data to Germany, to Sweden, and to Denmark. That's where our partners, they work in energy forecasting. They purchase global numeric weather data. They take the on-ground data from us, and then they juxtapose it, and they create a fantastic forecast, which is usually more than 90% accurate. They send it back to us every 15 minutes, and we embed that forecast here in the software right in front of you. Now, why that is so important, I think it's extremely important on two levels. I've always been concerned with the lower level, which is the plant. A plant needs this information. If he wants to carry out a routine maintenance, it makes sense to carry out a maintenance. For example, I'll schedule it after 10 o'clock tonight. I'll not allow the teams to go out and do any kind of repair work at the moment. Because if they shut down then, there's not going to be much loss of production, and vice versa. But even more importantly, for load balancing purposes from a utilities point of view, I think this is extremely, extremely crucial. We didn't realize so much over here, but when we started connecting to our Swedish customers, we realized how critical this information was. The penalties of giving a wrong forecast were severe. The penalties included immediate curtailments ordered by the grid operator if you were wrong in your forecasts. And then these forecasts were going to another entity, which is called a virtual plant that was trading on the behalf of small producers. So he needed incredibly accurate forecast information so that the grid could adjust the demand and supply and take the decisions on dispatching of their spinning reserves. But here for this project at Mehran, I think there is a very, very good case of another PhD, sir, Dr. Saab, if you're listening, another PhD on energy forecasting algorithms. The data is there. The global numeric weather data can be purchased by anybody on this planet. The airlines, the television channels, they all buy that data. And the operational data is available. So, you know, this can take off into another research program, and somebody can create an algorithm like that predicts, and maybe we don't have to send out data to Denmark and Sweden and Germany. So that was about the forecast. Few more features, breakdowns I mentioned. So I'll just give you a tool. I'll flash it in front of you. Pretty interesting tool. So it looks like right out of the Matrix movie, but it's actually simple. On the y-axis, you have the turbines. On the x-axis is time of 6 months. And these colored dots are all those occasions when those turbines shut down for some reason or the other. So that's a kind of a high-level view. And I can immediately notice a pattern over here. Yeah, thank you. So yeah, I can see something fishy has happened over here last couple of days ago. They just, every turbine has gotten afflicted. We'll go get a little deeper into that just to get you a taste of the tool and its capabilities. And ladies and gentlemen, this would be the easiest thing to build up, because you're getting the alarm logs of this power plant from its SCADA. You're getting the parameters, you're getting the event logs, and you're also getting the command logs. And how these logs are retrieved, stored, sorted, named, there are couple of IEC standards against that also. So that's a IEC 61425 series from 25-1 to 25-7. And those standards completely describe how these signals are supposed to be generated, named, sorted, stored, displayed. Nothing really magical here. So this display could be just as well made over here. So another thing that this kind of view tells us is that there's something fishy over here, but it also tells us that there's something terrible with 23 number turbine happened here and kept happening here and here. And then so you can say something similar about turbine number 10. Then yeah, this is really not doing very well. I'll just quickly delve a little bit deep so that you know what more you can do. So I'm going to zoom in now. I'm sorry, I'm not used to using the mouse, and my laptop wouldn't connect up with your existing setup. So I'm just going to zoom in over here. And so voila, we have some serious grid disturbances over here. So line side CCU faults, the list of faults is coming below. The frequency instability faults, low voltage faults. So, you know, a couple of instabilities that happened, they knocked out our turbines, they remained shut down for this much time. Some of them could restart, some of them were damaged. It took a much longer time to get them on, and so on and so forth. And this was, in this particular instance, there was a rainstorm, so there was a lot of disturbance on the grid. But then there are many other reasons, pitch, yaw systems, over temperatures because of our environment, and so on and so forth. So I'll just stop now. I don't want to take too much of your time. My whole inspiration was to get the students excited that you are going to lay your hands on the data very soon. You can make use of these standards which are out there. And I think your faculty can give you some very tough assignments, and you can get to the bottom of every problem that is happening to a live wind power plant from a great distance, but you can get to the bottom of the problems, and you can suggest ways and means to the owners and tell them that this one is a persistent problem, or this is how frequent you need to wash your turbines, or this is what you need to fix, so on and so forth. And hopefully all is said and done. There will be many MPhils and PhDs coming out of this program for many years, because these plants are out there for at least 20 years. And there will be generations of researchers who will make this university very proud. And I'm sure the regulators or the grid operators, they will have a more dependable, trustworthy source of academic research and data that they can rely on in order to take that into policy matters, rather than acrimonious relationship with very little trust in them. So hope it will work out for everybody. I'll thank Dr. once again, Dr. Bhavani. Sir, I've never been to a university. I don't know how it works. I'm just a private company, an entrepreneur, doing projects here in Pakistan and in Sweden. So beyond that, I really don't know, sir, how it works, but rest assured, sir, algorithm consulting, like we have sent out in the contract to you, sir, we remain committed to your academic research. We are not insecure. I think it's a payback time for us, because when we started this company 2 decades ago, we've always been the beneficiaries of the academic work done elsewhere, because that's always guided us. However, most of those papers were in Europe or in the West. And later on, some Chinese publications, they have helped us a lot. I hope with this data becoming available over here, and your students putting their focus into research, there hopefully would be a flurry of equally good papers coming out, inspiring so many other private companies. Thank you. If you got any questions, please ask. And don't be scared. I'm not a professor. I'm not grading you, and I'm not doing any of that thing. So you can ask whatever you want to. No, you're a professor. I'll not take your question. Yeah, you were asking something. I'll come back to you, Dr. Sam. Just pulling your leg. Please.
And I want to ask you a question. Yeah, I want to ask you a question. Have you used artificial intelligence or any machine learning algorithm for the forecasting of the wind turbine energy generation? Like, for example, if we take the data for 5 to 10 years, can we predict the generation for the year like 2022? Is it possible, sir?
I actually did. I worked very closely with another public sector university in Islamabad called ComSats. So there is a fantastic academic over there. His name is Dr. Naveed Rahman. So I started working with him on this forecasting, and started sending him the data and getting his feedback, and then sending him back whether he was right or whether he was wrong. So he was in the ballpark within a year of efforts. But unfortunately, when I was selling my software, because see, I'm a commercial guy, the ugly face of capitalism, and some would call that. But I got to make a living. So when I was selling the software to some of the customers here, they wouldn't take it with Dr. Naveed on it. They said, no, main bar ka chahiye. So I think we love shiny objects here in this country, probably the vestiges of being colonized for a long, long time. We don't trust our own doctors. I hope, I can promise you, if you develop that algorithm, I'll buy it from you for Sweden. Because we are working with a Swedish guy and we don't like him. His errors last week were 32%, and I can vouch for it that Dr. Naveed was less than 10%, but I couldn't use him because the Pakistanis wouldn't buy his algorithm. So is it a sob story or an inspiring story?
And actually, one more question I have.
Please.
Can you explain the effect of the weather on the wind turbine, like wind power generation? Because, for example, for the year 2021, we can generate more energy, but it is not the same for the like 2022 or 23.
Okay, so I'll just flash the figures right away. So we really don't have to go into any, debates or anything. It's science. So when you have the data, you will also have the same answers. And please remember, the IC standard in question is 61400-12-2, Rayleigh method. So we apply that and you'll see the results. So we don't have to say, oh, God was kind last year and he wasn't so kind this year, and we should pray to the deity to get the things okay. The data is out there. It's been there for 10 years. So I don't think so our interannual variation is more than 6% in this region. It's pretty stable. May I flash the data? Just give me a minute. And I'll show you what's happened in the last 5 years at a click of few buttons.
Sure, sir.
I'm struggling with this mouse. I wish my laptop was with me. So I'm going to an area called operational wind resource assessment. It's going to take a little time to load. It's data intensive.
Maybe I can communicate you after the session ends, or maybe at another time, sir.
No, it's
okay,
flashing now,
yeah,
so don't worry.
Yeah.
Okay, so it looks like a pretty silly curve. This is a variable distribution that you're watching on the bottom left, the green. But believe me, this has been built out of 21 million instances of the wind. So this is giving you the power density over the last 5 years at a click of the button. And then what happened each year. So that is also there. If I can only press it correctly. So this is what happened in 2016. So not much of a big deal. It differed on the left side. Left side doesn't matter because you produce so much less energy on the left side of the Weibull distribution. I can take a look at another year. Okay, a little bit. And I can tell you the energy in each year right away. So I'm moving to the next page. And you can see the wind rows and the energy rows on the right, which direction was the more predominant wind. So yeah, if you see 138, 135, 124, 129, and a standard deviation of only 5.4 by using our method. And if you use the IEC's method, the standard deviation is even less. It's 3.4 standard deviation, which means the spread of the data is pretty tight. And that means, you know, these sob stories that no, God wasn't kind this year, so we lost 20%. I think that's a fantasy. Maths is better. If you do it yourself is even better. And now you'll have the data, you can apply the IC standard and figure out yourself and make sure that you are able to help the policymakers here.
Thank you so much, sir.
Dr. Sorry for the child. You had a question, please.
I could see few percentages, which are more than 100%.
Yeah. Okay, yeah. So I think that must have been the performance ratio today. Yeah. Yeah. Let's go to the power curve. So you can pick up any turbine, you can select any date, and this will calculate you how well or badly your power curve is performing. These are the scatter plots. Below you have the time series data. And so what we are seeing is that on between 5th June and 15th June, how this turbine was behaving. And between 5th July and 15th July, how is it behaving? And if you want to know what has happened in terms of percentage wise, so we can flip this button over here. So we are 91% in June. And now we are 96.5%, because of course there was rain. So you can just pick up, and we are just talking about one turbine. Over here, you can go up, select any turbine and any date in the past, because when we give you the data, we will also be giving you the history. I think some of you were present in the meeting at the plant a couple of weeks ago. So the owners agreed that they will provide us the entire history since the commissioning of the plant. So that's fantastic. And that's Mr. Irfan's magic. I don't know how they give you. We have to sign 10 NDAs to get anything out of them. You can also use this, again, the IC methods, how to make power curves. I mentioned the standard. You can use those standards, make those power curves, the line graphs, the scatter graphs, the performances. So then you're not really discussing subjectivity anymore. You can drive out all subjectivity from how a wind power plant works. Absolutely. Does that answer your question, Doctor? Okay. All right. Okay. Yeah, I understand. So yeah, that's a very good question. That means that the anemometer is not performing very well. It is understating the wind, and that is why it is overstating the performance ratio, and that it should be reported to the O&M that this is not physics. Turbine can't be at 120%. So you're right there, sir. Yeah, you want to get rid of me. I got it. Thank you. Guys, any other questions from the students? I'd love to answer. Thank you. Thank you. It's an honor to be here, sir. I've benefited immensely from academia all my life with the research paper, white papers, books published, because those were all built into the products that I have been making. I think it's a time to for us to give back some of that. Thank you.
I'm sorry, I'm not that tall, so I need this tool to function properly. Anyways, thank you so much, Mr. Saqib Saeed. That was quite interesting, and I think that was first time for me and for most of them to see live data from power plants. So yeah, that was giving us quite realistic vibes. Before moving forward, for those of you who have joined now, let me introduce myself. I'm Falakna Sumro, Assistant Manager IEEE MUET. I'll quickly go towards the session. Agreement signing ceremony between Mehan University and Algorithm Pvt Ltd. For this particular reason, I would request Professor. Sure, why not? All right. I would like to call Chief Guest of the Day, Engineer Rafiq Sheikh, Vice Chairman NEPRA. Engineer Rafiq Sheikh have over 17 years of experience working in energy sector. Currently, he's working as member National Electric Power Regulatory Authority. Previously, he worked as business lead at OSIS Energy Consultants, improving business process and core business services of the utility company for their internal and external customers by using advanced analytics, redefining business processes, standing up big data analytic tools, making strategies to achieve the financial goals for strengthening the company's position. Before that, he was the Senior General Manager at K Electric. Thank you so much for the lighting. Before that, he was the Senior General Manager at K Electric Limited, where he was responsible for the regulatory affairs covering performance standards, licensing, consumer issues, and energy distribution business sustainability. Thank you so much, sir, for coming here. I would want you to come on the stage, and thank you.
I think she did the right job by skipping me. लेकिन डॉक्टर चौधरी साहब ने कहा कि नहीं जी शेख साहब को ले आए. Assalamu alaikum, students, honorable faculty, and other participants. Good evening. I think I would prefer talking in Urdu or Sindhi. I think Urdu is the national language, so I prefer talking in Urdu. अंग्रेजी मेरी बोलने में इतनी अच्छी नहीं है और शायद आप लोगों को समझ ना सके. मैं थोड़ा सा आपको तारुफ करवा दूं. नेशनल इलेक्ट्रिक पावर रेगुलेटरी, आई एम वाइस चेयरमैन देयर एंड आई एम आल्सो मेंबर फ्रॉम सिंध. नेशनल इलेक्ट्रिक पावर रेगुलेटरी अथॉरिटी का काम ये है कि पावर सेक्टर के रिलेटेड, चाहे वो जनरेशन हो, ट्रांसमिशन हो, डिस्ट्रीब्यूशन हो, उसको रेगुलेट करना, परफॉर्मेंस स्टैंडर्ड्स देना, लाइसेंसेस देना, टैरिफ देना, इवन आपकी जो छोटी छोटी एवरेज बिलिंग और बिजली ना मिलने की शिकायत को सुनना, उनका अजाला करना. वैसे जो ये आखिरी जुमला जब मैं बोलता हूँ तो मुझे टेंशन होने लगती है कि 10 हाथ खड़े हो जाएंगे जी हमारा मसला है बिलिंग का. तो मैं मोस्टली मैं इस चीज़ को अवॉइड करता हूँ. सबसे पहले मैं आई एम रियली हैप्पी टुडे ऑनेस्टली. एक तो जिस यूनिवर्सिटी से मैं पढ़ चुका हूँ वहीं पे आके सामने मैं आज स्पीच दे रहा हूँ. दैट इज़ कॉन्फिडेंस फॉर ऑल ऑफ यू कि इंशाल्लाह अल्लाह करेगा आप सब इसी तरह तरक्की करके आप इस जगह पे पहुँच सकते हैं. एग्जैक्टली नॉट फ्रॉम जामशोरो, लेकिन उस वक्त मेहरान यूनिवर्सिटी नवाबशाह, मेहरान यूनिवर्सिटी के अंडर में थी तो मैंने नवाबशाह से पढ़ा. मैंने इंजीनियरिंग वहाँ से किया था. इंजीनियरिंग करने के बाद somebody suggested me कि जी I shall go for CSS. CSS किया, पास किया, क्वालिफाई किया, लेकिन बना मैं इंजीनियर. और टुडे ऑनेस्टली आई एम प्राउड इंजीनियर. मेरे जितने भी दोस्त जो मेरे साथ CSS कर रहे थे, they always keep on telling me कि यार you are more fortunate than us. I'm just telling you this thing because एक हवा चली हुई है मुल्क में काफ़ी अरसे से कि इंजीनियर्स को शायद वो इतना इंकरेजमेंट नहीं मिलती सोसाइटी में जितना CSS ऑफिसर्स को मिलती है या फिर कहीं किसी और प्रोफेशन में मिलती है. तो प्लीज़ ट्रस्ट मी, दिस प्रोफेशन इज गोइंग टू गिव यू मोर एंड मोर रिस्पेक्ट अराउंड द वर्ल्ड, ग्लोबली, पाकिस्तान के अंदर, हर जगह पे. तो मेहनत करें और अल्लाह से दुआ करें, इंशाल्लाह आपके नसीब भी और अच्छे होंगे। हैविंग सेड दिस थिंग, तो दूसरी खुशी की बात आज भी नजर आई है, डॉक्टर इरफान साहब ने जो पहली प्रेजेंटेशन दी इनिशियली, he gave a new concept today, new thinking to a regulator, और जिस पे हम काम करके बहुत टैरिफ भी कम कर सकते हैं। आई एम जस्ट टॉकिंग सलीस उर्दू, ताकि हर मैं इजीली आपको अपने आप को एक्सप्लेन कर सकूं। हम एफिशिएंसी बेहतर कर सकें, हम उस कंटेंट को लोकली मैन्युफैक्चर कर सकें, जो हमेशा हमारे माइंड में ये है कि हम सिर्फ बाहर से ही इंपोर्ट कर सकते हैं। And I think fortunately this is the right timing for us, because 1 month ago as a regulator we started a debate कि किस तरह हम वो कंटेंट जो बाहर से मंगवाते हैं उसको हम लोकली मैन्युफैक्चर करवाएं, उसको एनकरेज करें, ताकि हमारी एक्सटर्नल चीज़ों पर डिपेंडेंस कम हो, लोकल एक मार्केट डेवलप हो जॉब्स के लिए, हमारे इंजीनियर्स को और बेहतर तरीके से बहुत यूटिलाइज कर सकें। और दूसरा, साकिब साहब प्रॉब्ली जो एल्गो से थे, इन्होंने जो एंगल बताई, इन्होंने पूरा का पूरा डेटा एनालिटिक्स आपके डोर स्टेप पे पहुंचा दिया, ताकि उसको आप बेटर यूटिलाइज कर सकें अपनी रिसर्च के लिए, अपनी थीसिस के लिए। और ये वो चीज़ है, पाकिस्तान में अब पावर सेक्टर, जैसे अभी बताया गया कि कितना वैक्यूम है हमारे पास पावर सेक्टर में, इसको हम बेहतर तरीके से यूटिलाइज कर सकते हैं, और हम अपने पावर सेक्टर की इनएफिशिएंसीज को काफ़ी हद तक ख़त्म कर सकते हैं। एक चीज़ डॉक्टर साहब, विद रेफरेंस टू योर डिस्कशंस अर्लियर इन द बिगिनिंग ऑफ सेशन, एक कॉन्सेप्ट मार्केट में चल रहा है, अखबारों में हर जगह पे, कि जी वी हैव जो एडिशनल कैपेसिटी है, सरप्लस कैपेसिटी है, सो वी डोंट नीड एनी मोर कैपेसिटी। मैं एक चीज़ बता दूं कि जो सूरज और हवा की बिजली है, ये रिप्लेसमेंट ऑफ कॉस्टली इलेक्ट्रिसिटी लिया जाए, इसको प्लीज़ एडिशनल कैपेसिटी ना लिया जाए। अगर आप चाहते हैं कि पाकिस्तान में अगले 10 सालों में बिजली के जो बिल आपके पास आते हैं वो कम हो, तो उसका एक ही तरीका है कि इसको रिप्लेस किया जाए कॉस्टली इलेक्ट्रिसिटी को विद सूरज और हवा की बिजली, जिसमें कोई फ्यूल इस्तेमाल नहीं होता, वो हमारा इंडिजिनियस रिसोर्स है। आपके डिपेंडेंस भी डॉलर्स पे कम हो जाती है। तो सबसे इम्पोर्टेंट तो पॉइंट ये है कि इस तरह का कॉन्सेप्ट बिल्कुल गलत है कि जी हमें कैपेसिटी की ज़रूरत नहीं है अभी, और इवन ये कहना कि सरप्लस कैपेसिटी इज इटसेल्फ अ डिबेट। अगर आप हमारी स्टेट ऑफ इंडस्ट्री रिपोर्ट को अभी शुरू में रेफर किया गया, अगर आप उसमें पढ़ें तो वहाँ पे एक अच्छी खासी डिबेट है इस मामले में कि सरप्लस इलेक्ट्रिसिटी हमारे पास है भी या नहीं है। देन ट्रांसमिशन की बात हुई, एक ऑनरेबल प्रोफेसर डॉक्टर साहब ने सवाल किया ट्रांसमिशन से कि हम प्राइवेट सेक्टर को इसको क्यों नहीं वो करते। तो प्राइवेट सेक्टर को डॉक्टर साहब, जस्ट फॉर योर नॉलेज, हमने रिसेंटली 2 प्रोविंशियल ग्रिड लाइसेंस दिए हैं। पहले ट्रांसमिशन एक सिर्फ फेडरल डिपार्टमेंट था, अब हमने 2 प्रोविंसेस को KPK और सिंध को प्रोविंशियल ग्रिड लाइसेंस दिए हैं, और वो भी ट्रांसमिशन कर सकते हैं। लेकिन इससे पहले भी सिंध ट्रांसमिशन एंड डिस्पैच कंपनी, सिंध वाज द फर्स्ट प्रोविंस जिसको, जो नूरियाबाद से करीब ही आपके वहाँ से 100 मेगावाट की ट्रांसमिट करता है बिजली, जो वो इलेक्ट्रिक को सेल कर रहा है, तो वो प्राइवेट एंड पब्लिक पार्टनरशिप के तहत लगाया गया है। तो ये ख्याल गलत है मेरे ख्याल से कि ये सिर्फ गवर्नमेंट के अंडर में। जहाँ तक डिस्ट्रीब्यूशन, मेरा सब्जेक्ट ऑनेस्टली स्पेशलाइजेशन में डिस्ट्रीब्यूशन है और रेगुलेशंस है, और जहाँ तक डिस्ट्रीब्यूशन का कॉन्सेप्ट है, डिस्ट्रीब्यूशन में ऑलरेडी वी हैव 2 to 3 लाइसेंसेस इन द प्राइवेट सेक्टर, इलेक्ट्रिक और बैरियर, और उसमें अभी हम रिसेंट नया एक और हम भी अभी और काम करने जा रही है गवर्नमेंट के, किसी तरीके से हम मैनेजमेंट कॉन्ट्रैक्ट्स को आउटसोर्स करें आपसे डिस्ट्रीब्यूशन कंपनी, ताकि आपके जो फेस्को, सेपको और लेस्को के हालात बेहतर हो सके। बातें बहुत हैं, कम से कम 2-3 घंटे बात कर सकते हैं मैं इस पे, लेकिन मैं अपने आप को बहुत स्पेसिफिक रखूंगा टू टुडेज टॉपिक। CSR पे आज मैंने न्यू फॉर्म ऑफ CSR देखा है, न्यू एंगल देखी CSR के, कि एकेडमिया, प्राइवेट सेक्टर और साथ साथ रेगुलेटर बैठा हुआ है, और वो बैठ के कुछ इस किस्म, इससे पहले हमारे माइंड में CSR ये था, जब हम किसी प्लांट पे जाते थे, पूछते थे यार आप CSR में क्या कर रहे हैं, तो वो कहते थे हम रमजान में शरबत देते हैं। तो ये था कॉन्सेप्ट CSR का, या जी रमजान में शरबत दे दिया, या फिर हमने कुछ छोटे मोटे काम कर दिए। लेकिन दिस कॉन्सेप्ट जो आज डॉक्टर इरफान साहब ने बताया, और हमारा जो हमारी CSR कंसल्टेंट है, उन्होंने मुझे ब्रीफ किया रास्ते में, कि इस कॉन्सेप्ट के तहत हम एकेडमिया, स्टूडेंट्स, रेगुलेटर, इन तीनों को कनेक्ट करेंगे आपस में, क्योंकि रेगुलेटर और ये तीनों आपस में मिलके स्टूडेंट्स की रिक्वायरमेंट्स इन टर्म्स ऑफ डेटा, स्टूडेंट की रिक्वायरमेंट इन टर्म्स ऑफ जॉब्स क्रिएशन, उसको इस एंगल से देखा जाएगा और उसको कवर किया जाएगा। सो दैट इज अ वंडरफुल कॉन्सेप्ट एंड आई रियली अप्रिशिएट द एफर्ट्स। और एक और चीज एज अ रेगुलेटर, मैं डॉक्टर साहब आपको आई कैन गिव यू कॉन्फिडेंस, जो एफिशिएंसी इंप्रूव करने के फैक्टर्स आज आपने हमें बताए हैं एक दो, आई कांट कमेंट यू कि हम इसको डेफिनेटली करने जा रहे हैं, लेकिन अगर ये प्रूफ हो जाता है थ्रू रिसर्च जो आज आपने बताई है, तो आई एश्योर यू वन थिंग, आई एम गोइंग टू मेक इट अ पार्ट ऑफ आवर स्टैंडर्ड्स। एक सर प्लीज, आई विल टेक योर क्वेश्चन, आई विल मेक इट पार्ट ऑफ द स्टैंडर्ड्स, क्योंकि हमारे जो टैरिफ डिटरमाइन करते हैं, जो भी चाहे विंड का हो, थर्मल का हो, सूरज की बिजली का हो, उसमें हम जो टैरिफ डिटरमाइन करते हैं, उसमें एफिशिएंसी इज वन ऑफ द कंपोनेंट। 22-24%, जो लास्ट हमने टैरिफ दिया है सोलर का, एनर्टेक का दिया है बलूचिस्तान में, आई थिंक इट्स 24% एफिशिएंसी। टेकिंग दिस अपॉर्चुनिटी डॉक्टर साहब एंड वाइस चांसलर साहब, I also request one thing. We have one challenge, especially with the wind and solar. That is a challenge of intermittency. मैं भी बात भी कर रहा था थोड़ी देर पहले, अगर इस पे भी कुछ रिसर्च हो जाए और वो रिसर्च हमारे साथ शेयर की जाए, तो हम इसको और बेहतर तरीके से, इन जो चैलेंजेस इंटरमिटेंसी में आ रहे हैं, इसकी वजह से हमारी यूटिलाइजेशन एफिशिएंसी में फ़र्क पड़ रहा है, हम इसको भी अपने स्टैंडर्ड्स का हिस्सा बना सकते हैं, उसको हम यूटिलाइज कर सकते हैं। उसमें आप जो भी इंफॉर्मेशन चाहेंगे हम आपको प्रोवाइड कर देंगे। Lastly, before I take question from Saqib sir, जिस किस्म की हेल्प, जिस किस्म का डेटा आपको चाहिए, रेगुलेटर इज विलिंग टू प्रोवाइड, चाहे वो CSR का एरिया हो, आपकी रिसर्च का एरिया हो। हमने लास्ट टाइम भी यहाँ पे रिक्वेस्ट की थी कि हमें इंटर्नशिप में डॉक्टर साहब से बात भी की थी उसके बाद फ़ोन पे, कि हमें बताएं हम किस तरह आपके लोगों को इंटर्नशिप दे सकते हैं। अब तो हमने एक CSR कंसल्टेंट हायर कर लिया है, जो आपके सामने बैठी हैं वो माँ। हमने स्पेसिफिक उनको टारगेट ये दिया है कि किसी तरीके से जहाँ जहाँ प्लांट लगे उस एरिया के लोगों को कम से कम इंटर्नशिप साल की। और एक और एडिशनल चीज़, पाकिस्तान इंजीनियरिंग काउंसिल के इत्तेफाक से कुछ लोग मेरे पास आए थे 3-4 दिन पहले, वो भी इसी लाइंस पे काम कर रहे हैं कि किस तरीके से हम, जैसे ही कोई बच्चा इंजीनियर बन के निकलता है, जिस तरह डॉक्टर को एक हाउस जॉब 1 साल के लिए करवाई जाती है विद स्टिपेंड, वो भी इस लाइन पे काम कर रहे हैं कि किसी तरीके से उस इंजीनियर को 1 साल तक किसी भी प्लांट के साथ, किसी भी के साथ हम अटैच करें, और उनको 1 साल तक कम से कम, ताकि उसको इंश्योर हो कि उसको स्टिपेंड मिले कुछ ऐसा, ताकि वो उसको 1 साल स्पेस, ब्रीथिंग स्पेस मिल जाए। Having said this, there are a lot of positive opportunities are coming in Pakistan. मैं स्टूडेंट्स को एड्रेस कर रहा हूँ, सो प्लीज़ कभी ये ना सोचा करें कि हमारा फ्यूचर क्या होगा। बहुत अच्छा फ्यूचर होगा, सेफ होगा। चैलेंजेस आते हैं, बहुत सारे चैलेंजेस आते हैं, लेकिन इंजीनियर्स का फ्यूचर बहुत पॉजिटिव है. I assure you after sitting at the very important position. So thank you very much. जी Sakir sir. You can answer by sitting again, please.
In deference to you, I'd rather stand. It wasn't so much a question, it was about dust, sir. So we could not, as a private company, we just could not sell our product to anyone in the wind sector unless we could prove that how much it improves. So what we did was we had done about 4 or 5 year long research on dust. So we sent this research to Turbine, which is a premier certification body based in Hamburg, Germany. And it took us 4.5 months when their experts saw all that data and they certified that yes, there is a 4 to 6% improvement in power generation after every wash. This is on record, and I'm absolutely willing to share the entire research of Turbine that we had submitted to them. Exactly that. I'll hand it over to Dr. Saab. So yes, this is a grave issue which hasn't been taken into account by anyone. I didn't realize this, but this was equally a grave issue in Sweden because of the icing on the blades. And the same research is used over there. So, sir, I'm signed up with a federal government body over there called SMHI, Swedish Meteorological and Hydrological Institute. So I'm supposed to place 20 servers all across Sweden and give them the losses because of the icing directly to their offices in Stockholm, sir. So this one is a pretty real thing, sir. So I think if I share the research and you can order some more research, you can involve some other third party, you will get a hang of this. 6 to 11% is a huge thing, sir, that can do a lot of that. So that is my 2-bit. My second, sir. And of course, I wasn't aware of this forecasting issue, how big a thing it was. And here it isn't. Here, sir, I think a lot of plants, they do their own forecasting. They hire some foreign consultant. And some plants are waived off because when they were commissioned, this requirement wasn't there. So we got a hodgepodge of forecasts. We got some kind of plants which are forecasting and some are not. And on the receiving end at the CPPA, as things stand today, they don't have the capability to collect all of this and make a meaningful dispatch out of this. And when I look at it from the Western perspective, sir, it is the most critical thing for sale or purchase of electricity. So, and I really don't know why we are ignoring it. This technology is there. Those forecast service providers are there. And the irony over here is, sir, if your errors tend to go down if you do a collective forecast of a region, and your errors move up if you just keep a focus on a single plant, sir. So I think there is a very good case for collectively doing a forecasting for all the wind power and solar power energy involved, and help out with your spinning reserves and your dispatching plans, sir. So that's just my 2-bit as a private person, sir. Thank you.
Okay, my brother, you discussed about 2 things: 6% efficiency, increase in 6% efficiency because of the initiative which Yusuf have told, and number 2 is your forecasting. As I told you that we have hired one research analyst recently 2 months ago, and he has been given an assignment. What I'm going to do immediately after I join Islamabad and back to my office, we'll collect your data, we'll get your case, and because we are being a regulator, we are a quasi-judicial body, so we can't like the private sector. I had been working in private sector and distribution side, Nigeria and everywhere. In government sector, and especially on the regulator side, we have to work under the rules and regulations. But having said this, I assure you one thing, as I said earlier, that the data which you are going to share with us, our consultant will talk to you directly, and inshallah we'll try to incorporate that data into our mechanism. And number 2, we'll also prevail CPP and other agencies to please do whatever you're suggesting them if that is proved right by our research team. So thank you once again for your questions. Yes, please. Please don't ask me about the load shedding and everything, please. जी मेरा अंदाजा है आप स्टूडेंट नहीं है, आप मीडिया से हैं मेरे ख्याल से। अच्छा ठीक, आपने सिंध गवर्नमेंट का नाम लिया, फिर आपने किसी प्रोजेक्ट का नाम लिया घोटकी में, तो मुझे लगा कि शायद आप अपनी अच्छी खासे तैयारी करके आए क्वेश्चंस के लिए। मेरे भाई सबसे पहले तो हम खर्चा नहीं करते, हम खर्चा लेते हैं। हम टैरिफ डिटरमाइन करते हैं, हम उनको मजबूर करते हैं, मजबूर नहीं, उनको एज पर लॉ कहते हैं कि जब बिजली खरीदेंगे और बिजली बेचेंगे, ठीक है। तो खर्चा करना हमारा डोमेन में आता भी नहीं, ना हमें गवर्नमेंट की ऐसी पॉलिसी कि हम CSR में खर्चा करें। नंबर 2, आपने बहुत एक अच्छी बात कही कि सिंस इंडिपेंडेंस शायद हमने CSR पे इतना काम नहीं किया, लेकिन मैं आप लोगों से एक रिक्वेस्ट करूंगा, आप किसी दिन ना थर का चक्कर लगा के आए। आई हैड माई सेल्फ गॉन देयर, आप जाके देखें एंग्रो ने और सिंध गवर्नमेंट ने जो वहां पे काम किया है, और उसके बाद आप ना इस क्वेश्चन को जरा रिफ्रेश कीजिएगा। जितना जबरदस्त काम वहां पे हुआ है, अगर आप, मैं आई एम नॉट हेयर रिप्रेजेंटिंग एनी प्राइवेट सेक्टर, लेकिन क्योंकि मैंने इसको खुद देखा है, वहां पे उन्होंने लोकल वहां के लोगों को, वहां पे मियाँ बीवी अगर हैं तो बीवी को उन्होंने, खातून भी ड्राइविंग कर रही है, बड़े बड़े डैम्पर्स, और उनके जो हस्बैंड है उनको भी, और हर किसी को अलग अलग 500 गज का घर दिया है। बहुत जबरदस्त काम हुआ है वहाँ पे CSR, जितना नंबर 1। नंबर 2, मैं अपने आप को रेस्ट्रिक्ट थर तक नहीं करूंगा, क्योंकि आई हैव बीन विजिटिंग ऑल ओवर द पाकिस्तान। काफी ऐसी अच्छी जगह और भी जहाँ पे CSR पे काम हो रहे हैं, लेकिन छोटे छोटे प्लांट्स नहीं कर रहे। जैसे मैंने शुरू में कहा कि वो रमजान में शरबत बेच के दे के खुश हो जाते हैं। दैट इज वाई वी फेल्ट द नीड ऑफ द कंसल्टेंट। और 3-4 महीने पहले, हम आपको कितना अर्सा हुआ, 8 महीने पहले ये इनको हमने हायर किया है स्पेसिफिकली फॉर दिस टास्क, कि ये CSR पे काम कर सके। मैं आपके सवाल को जवाब देता हूँ। तीसरा सवाल आपने पूछा, ऑनेस्टली स्पीकिंग वी डोंट हैव एनी स्ट्रॉन्ग सपोर्ट बाय द लॉ व्हिच रेगुलेटर्स ब्रिंग। ये हम जो भी कुछ कर रहे हैं, इसीलिए हैव यू एवर सीन बिफोर, हमारे ऑनरेबल प्रोफेसर्स यहाँ बैठे, इनसे पूछे कभी कभी रेगुलेटर इस यूनिवर्सिटी में आया है पहले? ये हमने ही शुरू किया कि आपके हम हर यूनिवर्सिटी में जा रहे हैं, उनके साथ हम ये CSR के कॉन्सेप्ट, सेफ्टी के कॉन्सेप्ट और रिसर्च के कॉन्सेप्ट हम इंट्रोड्यूस कर रहे हैं। उसमें भी हम पे अभी बहुत से क्वेश्चंस आ रहे हैं, हम आपको शायद बाद में बता देंगे इस बात पे कि कितने कंसर्न्स रेज किए गए कि ये लीगली आप कर नहीं सकते इस बात को, लेकिन वी आर टेकिंग इट इनिशिएटिव, और इंशाल्लाह यू विल फाइंड अ चेंज इन नो टाइम। प्लीज
सर, मैं आपने थर का मिसाल दिया, तो मैं थर के मामले में बात कहूँगा कि जो थर में है, थर में जो इश्यूज हैं, वहाँ पे बड़े अच्छे रोड तो बन गए। मैं गया हुआ हूँ, मैं काफ़ी दफ़ा जाता हूँ वहाँ थर में, मेरे काफ़ी दोस्त भी हैं। तो जो थर में उन्होंने डेवलपमेंट की है, उससे ज़्यादा उसकी नीड है थर में। और दूसरा ये कि आपने रोड तो आपने बना दिए, वहाँ पे अभी तक लोग जो हैं, वहाँ पे पानी का इशू है सर।
मेरे भाई,
वहाँ पे
दिस इज अ पॉलिटिकल डिस्कशन, आई विल
सर, ये पॉलिटिकल की नहीं हुआ रहा में, क्योंकि ये एंग्रो जो माइनिंग कंपनी है, वहाँ पे जितना काम कर रही है, अभी रिसेंटली 1-2 बिल का एक वाकया हुआ है, अगर आपको पता हो तो।
Any other question? I would not take any political discussion. जी लास्ट प्लीज। मैं मुझे कहा गया था कि मुझे सिर्फ स्पीच देनी है, प्लीज बताएं। बिजली का मामला आता है ना, क्वेश्चन बहुत रोज हो जाते हैं। जी प्लीज। वो डॉक्टर साहब सही थे, उन्होंने अंग्रेजी में डिबेट की और
can we manufacture the solar power, solar panels and the?
That is very good question.
Yeah.
आपको जवाब शायद पहले उन्होंने बहुत डिटेल से डिस्कस किया जी, क्वेश्चन पूरा करें। हम अपना मैन्युफैक्चर कर सकते हैं, नहीं कर सकते?
Can you discuss that we can manufacture locally the solar panels and the parts required for the like wind turbine?
देखिए, इसमें आपका क्वेश्चन बहुत पर्टिनेंट है और कुछ प्राइवेट सेक्टर ने कोशिश भी की थी, जहाँ तक मेरी नॉलेज है डेस्कॉन ने शायद कोशिश की थी कोई यहाँ पे आके मैन्युफैक्चर करें अपने ब्लेड्स, लेकिन इसमें काफ़ी नेशनल एज वेल एज इंटरनेशनल एसोसिएटेड फैक्टर्स हैं, जिसको अगर मैं अभी यहाँ पे डिस्कस करने लगूँ तो शायद पूरी एक घंटा गुजर जाएगा, लेकिन प्रैक्टिकली इट्स नॉट पॉसिबल नाउ। हाँ, एक चीज़ हम कर रहे हैं, जैसे मैंने जिक्र किया कि हमने एक रिसर्च एनालिस्ट अभी हायर किया है, उसको स्पेसिफिक टारगेट ये दिया है कि ठीक है हम बड़ी बड़ी चीज़ें तो नहीं मैन्युफैक्चर कर सकते, लेकिन काफ़ी ऐसी ऐसी चीज़ें होती हैं, छोटी छोटी चीज़ें होती हैं, कम से कम वो तो मैन्युफैक्चर कर सकते हैं। तो उसके लिए भी हमें काफ़ी प्रॉब्लम्स आ रहे हैं, लेकिन इंशाल्लाह हमारा काम है रिसर्च करना, हमारा काम है गवर्नमेंट ऑफ पाकिस्तान को रिसर्च बेस्ड एडवाइजरी भेज देना, गवर्नमेंट हैज़ टू टेक डिसीजन। Having said this, thank you very much, and Dr. Saab, Professor Saab, thank you very much, and Irfan Saab for inviting this on this prestigious institution. I really proud, feel proud कि जी मैं यहाँ पे आज खड़ा हूँ और दूसरी दफ़ा मैं आया हूँ। 2 दफ़ा आने से पहले आखिरी दफ़ा जो मैं आया था, मैं अपनी मार्कशीट के लिए आया था, मैं 2 घंटे बाद धूप में खड़ा रहा था, क्योंकि मैं नौशाह में पढ़ता था और मुझे पता चला जी मुझे मार्कशीट यहाँ आके लेनी है, तो गुम हो गई थी, तो मुझे वो सब ऑनलाइन हो गई। माशाल्लाह, थैंक यू जी एवरीवन, थैंक यू मच।
Thank you so much, sir, for interactive speech. I hope सबको बहुत अच्छा लगा होगा और थैंक यू उर्दू में स्पीच करने के लिए, सबको अच्छी तरीके से समझ भी आ चुका होगा। थैंक यू सो मच। Alright, so now we'll be moving towards agreement signing ceremony between Mehran University and Algorithms Pvt Ltd, and also MOU signing between Mehran University and IEEE Karachi Center. For that particular reason, I would like to call Professor Dr. Muhammad Aslam Uqaili on the stage, and also Professor Dr. Bhavani Shankar Chaudhary, along with Engineer Rafiq Sheikh, Engineer Saqib Saeed, and Engineer Khalid Parvez. I would also request Professor Dr. Tanveer Hussain, Engineer Irfan Ahmed, Mr. Zishan, and Dr. Nair to kindly come on the stage. Oh.
No, of course.
Okay. So I would request Professor, yes, I would request Vice Chancellor to kindly give souvenirs to the guests, the chief guest. Yes. I would request the shield to be given to Sir Saqib Saeed. Request the token of appreciation to be given to the to Sir Irfan. Okay. A memento for Madam Huma Zafar, please. Kindly come on the stage. Thank you. Yes, I would request Professor Dr. Bhavani Shankar to present souvenir to the NEPRA, to our chief guest today, as well as the nazam written by him. I would request Professor Dr. Bhavani Shankar to give Ajrak and nazam to Sir Irfan. I would request Professor Dr. Bhavani Shankar to present souvenir to Sir Saqib Saeed, Ajrak, as well as nazam. I would request our Vice Chancellor to present Ajrak to Sir Khalid Pervez. As well as nazam by Dr. Bhavani Shankar Chaudhary. I would request CSR consultant NEPRA, Ms. Huma Zafar. Ms. Huma Zafar is a believer who creates an impact and delivers through global, regional, and local partnership for sustainable businesses and development. She is a practitioner who successfully contacts every socioeconomic problem to amicable, holistic, inclusive, profitable business and solutions. And Ms. Huma is a marketer who understands how to sell an idea to create an impact on relevant audience and increase brand's demand, build brand's image, and result in revenue generation and sustainable economic development. And that is something that I would love to learn from her. Please, Ms.
Let me interrupt you in a while. Before you start your presentation, I would request you to come on stage so that our host of this event should present you the whole Ajrak.
My student also.
Nazam of Dr. Bhavani Shankar.
I want to thank VC Saab, Aslam Saab, Dr. Bhavani Shankar Chaudhary Saab, and Irfan Saab, who is basically leading the project of CSR. I want to thank you all for giving me this opportunity to talk to the most distinguished faculty of Pakistan. And I truly feel privileged to talk to the students of Mehran University. मैं अभी कराची से विजिट करके आ रही हूँ एंड अभी सिंध गवर्नमेंट के जो एनर्जी सेक्टर में भी मैं गई थी एंड जिससे भी मैंने बात की most of the people were Mehran University graduates. So it's wonderful to know कि मेहरान यूनिवर्सिटी के ग्रेजुएट are at leading positions in in government of Pakistan, in private sector, private power sector as well. यहाँ पे बात हो रही थी और एक क्वेश्चन भी पूछा था एक स्टूडेंट ने अबाउट CSR, अबाउट लेजिस्लेशन, CSR का क्या लॉ है. आई विल आंसर दैट क्वेश्चन एज वेल. तो उससे पहले इट्स अमेजिंग टू सी कि किस तरह डॉक्टर इरफान साहब ने जो एक प्रेजेंट किया कि CSR इज क्रिएटिंग वैल्यू फॉर द स्टेक होल्डर. इट्स वेरी इंपॉर्टेंट टू अंडरस्टैंड. हमारी बहुत मिसकंसेप्शन है यहाँ पे. जैसे VC साहब, रफीक शेख साहब ने भी बताया कि पहले बहुत ही नैरो कॉन्सेप्ट था अबाउट CSR कि जी CSR सिर्फ चैरिटी है. इट्स वे बिगर देन दैट. इस पोडियम पे खड़े हुए मैं इस अपॉर्चुनिटी को वेल करना चाहती हूँ बताने के लिए कि वी ऑल शुड मेक पीपल अवेयर ऑफ रियल स्कोप ऑफ CSR और हम इससे कितना डिफरेंस क्रिएट कर सकते हैं. Going back to the creating value of stakeholders, so basically CSR is taking care of interest of all stakeholders. When we talk about stakeholders, that means हमारे पावर सेक्टर में, मैं पावर सेक्टर से रिलेट करूंगी इसको. पावर सेक्टर में स्टेक होल्डर्स, हु आर द स्टेक होल्डर्स? द कंज्यूमर्स आर, द प्राइवेट सेक्टर IPPs आर, गवर्नमेंट इज, एंड द प्लैनेट. तो हम जब स्टेक होल्डर्स की, एंड पीपल ऑफ कोर्स, तो हम जब बात करते हैं स्टेक होल्डर्स के इंटरेस्ट की, तो इट इंक्लूड्स एवरीवन विच इज और हु इज पार्टिसिपेटिंग इन द पावर सेक्टर, ऑपरेशन से लेके एंड द होल द सप्लाई चेन गेट इन्वॉल्व्ड इन द स्टेक होल्डर डेफिनेशन. ये जो प्रोजेक्ट आज स्टार्ट हो रहा है CSR का, इट्स अ वेरी इनोवेटिव एंड वन ऑफ इट्स ओन काइंड ऑफ CSR प्रोजेक्ट, जिससे हम जो पावर सेक्टर को मल्टीपल वे से बेनिफिट करेगा. डेफिनेटली मैं टेक्निकल बेनिफिट्स में ज़्यादा जा भी नहीं रही एंड आई डोंट नो मच अबाउट दैट, बट येस CSR के पॉइंट ऑफ व्यू से, सोशल पॉइंट ऑफ व्यू से, सस्टेनेबिलिटी के पॉइंट ऑफ व्यू से अगर हम देखें तो आई थिंक इट विल ब्रिंग अवेयरनेस to the people who consider CSR as just charity and nothing more. Or it will also equip the fresh graduates, with the hands-on experience, and will open up doors of endless opportunities in form of local jobs, as well as it will also prepare the graduates for the global markets. So I believe कि इस तरह के CSR के projects और ये जो academia industrial linkage है, जिसमें बहुत बड़ा gap है, it's high time to fill that gap. और we as regulator, हमने जब 8-9 महीने पहले when I joined CSR as in CSR consultant, जब मैंने NEPRA को join किया, तो I was shared with a vision of chairman NEPRA, and he said कि what we want, हम चाहते हैं कि जब power आए तो power के साथ prosperity भी आनी चाहिए. So we developed a vision, power with prosperity. So we thought कि हमारी कम्युनिटीज जहाँ पे पावर सेक्टर प्ले कर रहा है या ऑपरेशंस कर रहे हैं, उस कम्युनिटी को भी इंक्लूसिवली पार्टिसिपेट करना चाहिए. द प्रोग्रेस शुड बी इंक्लूसिव, इट शुड बी होलिस्टिक, एंड इट शुड बी सस्टेनेबल. और यहाँ पे मैं आई जस्ट वांट टू शेयर वन मोर थिंग कि CSR इज बेसिकली ट्रिपल बॉटम लाइन. Everyone around the world, अगर हम इंटरनेशनल उसकी मार्केट की बात करें, इंटरनेशनल स्टैंडर्ड्स की बात करें, मेरे ख्याल से जितने भी प्राइवेट IPPs जो हैं, वो सब लोग इंटरनेशनल स्टैंडर्ड्स को फॉलो कर रहे हैं, एंड दे हैव टू गिव कंप्लायंस टू दो स्टैंडर्ड्स. और उन स्टैंडर्ड्स में क्लियरली CSR के सोशल इन्वायरमेंटल और स्टैंडर्ड्स दिए गए हैं और उसको वो कंप्लायंस भी करते हैं. लेकिन जब हम उसको लोकल लेवल पे देखते हैं तो वहीं पे ये क्वेश्चन खड़ा हो जाता है कि जी कॉर्पोरेट सोशल रिस्पॉन्सिबिलिटी का क्या ताल्लुक है, सोशल इशू का क्या ताल्लुक है विद द पावर सेक्टर. I think it's a part and parcel of the power sector. कोई कहीं पे भी जब operations होंगे तो you have to be very vigilant about the impacts your operation or your business is creating. You have to manage the environmental as well as the social impacts of your operations, and it has to be taken care of. It's the first responsibility of any business person. So अब हमें aware करने की भी ज़रूरत है. I just want to share one more thing. VC साहब रफीक शेख साहब ने हमें मतलब he gave us time and he joined this ceremony as a chief guest. He was the person who initiated the CSR and made a CSR as a part of license agreement. जो हम IPPs के साथ license agreement करते हैं उसका इन्होंने इसको part बनाया है. अब CSR is something nobody can avoid. So it has creating its required space. And we are working on different lines कि हम कैसे लोगों को aware करें कि it's about growing people, it's about saving planet and it's about securing profits. उसमें हम किस तरह sustainable business की तरफ move कर सकते हैं. और हमारा जो NEPRA का mandate है उसमें we have to provide services जिसमें हम sustainable, reliable और affordable बिजली हमने provide करनी होती है. तो उसमें CSR का एक बहुत ही important role हो सकता है और हम we are gearing up ourselves to play that role. जो आपने बात की सिंध गवर्नमेंट लेजिस्लेशन की आपने बात की, तो लेजिस्लेशन में सिंध गवर्नमेंट ने कमेटी भी बनाई और एंड दे आर थिंकिंग ऑन द लाइंस कि वो उसमें मैंडेटरी कर देंगे सिमिलर जैसे पावर ऑयल एंड गैस में है, इसी तरह 1 to 2% दे आर थिंकिंग के 1 to 2% मैंडेटरी कर दिया जाए ऑन पावर सेक्टर. और उसमें सिंध में वो अप्लाई करने के लिए दे आर हैविंग डिफरेंट मीटिंग्स और उसमें वो दे आर गोइंग टू वो बहुत जल्द जो है वो लेजिस्लेशन का पार्ट बन जाएगा. एंड आई थिंक ये बहुत अच्छा वे फॉरवर्ड होगा. And I want to congratulate in the end and thank Mr. Bhavani and VC Saab as well as the Irfan Saab, because people like you should come forward and make Pakistani industry aware of the fact that CSR is more about business sustainability. It's more about attracting international market in international investors in Pakistan to rely on Pakistan's community and to rely on Pakistan's industry and to create more business opportunities locally. Thank you so much.
Thank you so much, Ms. Huma. It was so nice listening to you. And thank you, आपने उन बच्चों के questions का answer किया. So we appreciate it. There is no end to education. It is not that you read a book, pass an examination, and finish with education. The whole of life, from the moment you are born to the moment you die, is process of learning. To keep up the momentum of learning, I would request Engineer Khalid Parvez to please enlighten us regarding IEEEP. I'm so excited to call you on stage, sir, because आप हमारे VC साहब की टीचर हैं, तो आप हम सबके भी उस्ताद हुए और बहुत अच्छा वो लम्हा था जिसमें आप लोग मिले और हम सबको रिमाइंड करवाया कि हम कहाँ पर भी किसी भी एज में पहुंच जाए, हमें उस्तादों का उसी तरह से इज्जत और एहतराम करना है. Thank you so much for coming, sir.
Bismillahirrahmanirrahim. Nahmaduhu wa nusalli ala rasulihil kareem. Assalamu alaikum and a very warm afternoon. Uqaili साहब से आज मिलके जो खुशी हुई है उसका मेरे ख्याल है बड़ा अच्छा इजहार आप सबके सामने हुआ है. You really made my day, and that is what happens when I meet most of my ex-students. अल्लाह का बड़ा एहसान है, अल्लाह ने बड़ी इनके हवाले से स्टूडेंट्स के हवाले से इज्जत दी है और ये मैं समझता हूँ किसी भी टीचर का एक बहुत बड़ा सरमाया होता है. मेरा स्टार्ट क्योंकि टीचिंग से ही हुआ, शुरू के 15 साल NED यूनिवर्सिटी में मैंने पढ़ाया, उसी दौरान अमेरिका से MS किया और 34 साल से प्रोफेशन में हूँ. कंसल्टेंसी और प्रोजेक्ट मैनेजमेंट ये मेरे एरियाज से जो रहे. IEEEP एक बड़ा फाल इदारा है, लेकिन उससे पहले मैं कुछ कहूँ मेहरान यूनिवर्सिटी के बारे में कहना चाहूँगा कि मुझे बड़ी खुशी है जिस तरीके से मेहरान यूनिवर्सिटी की एक कुछ ट्रेडिशन रही है, एक हिस्ट्री रही है इसकी, जिसमें के बहुत ही बेहतरीन किस्म के बिलखसूस इलेक्ट्रिकल इंजीनियरिंग डिपार्टमेंट में टीचर्स रहे हैं। मुझे याद है डॉक्टर AR मेमन साहब होते थे, डॉक्टर राजपूत साहब होते थे। ये वो हजरात थे जिनके साथ मेरा इंटरेक्शन उस वक्त होता था जब मैं यूनिवर्सिटी में पढ़ाता था। वंडरफुल पीपल रियली। और वैसे भी उन्होंने जितने खिदमत की है इस इदारे की और इस इलेक्ट्रिकल इंजीनियरिंग डिपार्टमेंट को, इलेक्ट्रॉनिक्स वगैरह को डेवलप करने की, वो अपनी मिसाल आप है। IEEEP एक बड़ा फ़ाल इदारा है और हमने अभी नई काउंसिल ने अप्रैल में ही शुरू किया है काम। इससे पहले ये एजाज़ या ये कह लीजिए ये ऑफिस जो था इरफान साहब के पास हुआ करता था, हमने अभी इसको आगाज़ किया है और हमने कोशिश ये की है कि इसको ऐसे पैटर्न्स पे लेके चलें, कोशिश कर रहे हैं और उसमें अल्हम्दुलिल्लाह खासी हद तक कामयाबी भी हुई है कि हम बहुत सारी चीज़ें ऑनलाइन लेके आ गए हैं। हमने एक न्यूज़ लेटर शुरू किया है, मंथली होगा, उसका दूसरा जून में एक निकला था, अब जुलाई में जो था वो निकल रहा है, आने वाला है, एक सप्लीमेंट भी है। इसी तरीके से हम खासा कोशिश इसमें हमारा प्लान है और हम कर रहे हैं ऑलरेडी कि हम एकेडमिया के साथ बहुत अच्छा एक इंटरेक्शन करें ताकि हमारे फैकल्टी मेंबर्स और इसी तरीके से हमारे स्टूडेंट्स जो हैं वो उससे मुस्तफ़ीज़ भी हों। फ्यूचर उन्हीं का है, आप लोगों का फ्यूचर है, फ्यूचर इज़ इन योर हैंड्स। तो आपने जिस तरीके से उसमें कंट्रीब्यूट कर सकते हैं किसी भी इंस्टीट्यूशन के डेवलप करने में, उसके लिए हम कोशिश कर रहे हैं कि एक अच्छा आपको एक प्लेटफॉर्म मुहैया कर सकें। एक यूट्यूब चैनल हमने शुरू किया है IEEEP का, उस पर हम जो हमारे मुख्तलिफ वो चीज़ें होंगी, स्टूडेंट सेमिनार हमने मार्च में किया था, वो उसके प्रेजेंटेशंस वगैरह उस पर मौजूद हैं। इसी तरीके से हमने अभी एक वेबिनार किया था सिग्निफाई के साथ मिलके, वो हम उस पर डाल रहे हैं और इसी तरीके से हमारे काफ़ी प्लान्स हैं वेबिनार्स वगैरह करने के, वो भी हम उसके ऊपर अवेलेबल हो जाएंगे। दूसरी चीज़ हमने ये की है कि IEEEP की मेंबरशिप हासिल करने में बड़ी दुश्वारी होती थी, तो उसके लिए एक ऑनलाइन सिस्टम हमने डेवलप कर दिया है ऑलरेडी, इट इज़ देयर, और उसमें जितना सारा कुछ उसके ज़रिए से ही हो सकता है। तो ये कुछ चीज़ें हैं जिस पर हम काम कर रहे हैं। आज यहाँ जो बात की जा रही है CSR के हवाले से, और इसमें ये आपने भी बताया कि ये यकीनन पहला मौका है जिसमें कि एकेडमिया, प्राइवेट सेक्टर, रेगुलेटर वो एक साथ यहाँ जमा हैं। तो मैं इसको चीज़ को आगे बढ़ाना चाहूँगा और इसमें मैं समझता हूँ कि ये CSR का जो वेन्यू है ये बड़ा ब्रॉड स्पेक्ट्रम हो सकता है। इसमें बहुत सारी चीज़ें जो हैं हम आपके साथ इंटरेक्ट कर सकते हैं और आपको हैरानी होगी ये सुन के स्टूडेंट से मुखातिब हो कि पाकिस्तान में जो इलेक्ट्रिसिटी रूल्स इस्तेमाल हो रहे हैं, इलेक्ट्रिसिटी एक्ट है, वो पाकिस्तान से के बनने से पहले का है। 1937 का इलेक्ट्रिसिटी एक्ट है, 1940 के इलेक्ट्रिसिटी रेगुलेशंस हैं, उनको तब्दील करने की अशद ज़रूरत है। और मैं ये ऑफ़र करना चाहूँगा कि हम IEEEP कराची सेंटर के प्लेटफॉर्म से वी आर रेडी टू कंट्रीब्यूट इन दिस नेशनल कॉज कि हम उसको अपडेट करें। इलेक्ट्रिसिटी एक्ट नेचुरली वो तो असेंबली से पास होगा, लेकिन उसके लिए कोई ग्राउंड वर्क जो है हम उसमें कंट्रीब्यूट करने को तैयार हैं, कर सकते हैं। और यू कैन इंटरेक्ट विद NEPRA, रफीक साहब, वी कैन हेल्प यू, वी कैन जॉइंटली हैंडल दिस। और इसमें हमारे दूसरे साथी भी IEEEP कराची सेंटर के यहाँ मौजूद हैं, तो ये सब की तरफ से मैं ये ऑफ़र एज चेयरमैन कर रहा हूँ कि हम मिलके कोई काम करें। दूसरा जो एक बहुत बड़ा मसला है, आपने भी उसका तस्करा किया, वो सेफ्टी का है, स्टैंडर्ड्स का है। हमारे अनफॉर्चुनेटली हमारे पास कवानीन तो लिखे हुए हैं, उन कवानीन पे अमल नहीं होता। पिछले साल के जो हुआ था मानसून का सीजन, 36 डेथ्स हुई थी इलेक्ट्रोक्यूशन से। This is unacceptable at all. किसी भी मुआशरे में ये unacceptable है कि इलेक्ट्रोक्यूशन के जरिए से 36 संवाद हो जाएं किसी एक मानसून सीजन, ठीक है, which clearly indicates कि हमारे सिस्टम्स में खराबी, उसको ठीक होना चाहिए। उसके जो भी इसमें जो जिम्मेदार हैं उनको उसकी सजा भी मिलनी चाहिए और उसका एक तदारुक होना चाहिए ताकि ये आइंदे ये मसले ना हो। तो उस हवाले से हमारी भी रिकमेंडेशंस हो सकती हैं, हमने काम भी किया है उसके ऊपर, और उस हवाले से भी हम चाहेंगे कि हम नेपरा के साथ मिलके कुछ एक जिसको कहा जाए कि एक अच्छा गुड कंस्ट्रक्शन स्टैंडर्ड हम उस पर कुछ काम कर सकें और इस हवाले से हमारे सिस्टम्स का इम्प्रूवमेंट हो सके। थैंक यू सो मच।
सर मैं बहुत अच्छा आपने पॉइंट रेज किया। सिंस यू हैव रेज्ड इट, और एज अ रेगुलेटर मैं बताऊं हमने क्या किया था। जो 36 डेथ हुई थी, आप कराची की बात कर रहे हैं, कराची और बाकी डिस्ट्रीब्यूशन कंपनीज में भी हुई थी। इन द हिस्ट्री फर्स्ट टाइम हमने डिस्ट्रीब्यूशन कंपनीज पे मोर देन 100 मिलियन फाइन लगाया। ना सिर्फ फाइन लगाया, once again I would say we went beyond our law। हमने हर फेटल एक्सीडेंट्स की फैमिली को कंपनसेशन दिलवाई 3.5 मिलियन ईच, और दिलवा के उनसे सिग्नेचर लेके वो हमारे पास जब आई तो हमने उसको फिर और अभी क्लोज नहीं हुई। तो ये जितना हम कर सकते हैं, क्योंकि हमारे स्टैंडर्ड्स में लॉ इतना ही कहते हैं कि वी आर नॉट कोर्ट्स, तो बाकी तो कोर्ट्स का काम है। जितना हम फाइन, आपने स्टैंडर्ड्स की बात की तभी मैं बता रहा हूँ कि स्टैंडर्ड्स के अंदर हमारे पास एक मैकेनिज्म है, हम फाइन लगा सकते हैं, लेकिन हम फाइन से बियॉन्ड गए थे इस दफ़ा। और तीसरी बात, कराची में जो डेथ हुई थी उसका पता चला अर्थिंग का सिस्टम प्रॉपर नहीं था। हमने पूरी अर्थिंग करवाई, अर्थिंग करवा के एक थर्ड पार्टी से हमने वेरीफाई करवाया। थर्ड पार्टी ने हमें रिपोर्ट दी कि कहीं कहीं पे अभी भी लीकेजेस हैं। हमने फिर उसको फर्दर हमने इसको ठीक किया है और 3-4 जगहों से हम उसको फर्दर वेरीफाई करवाया। दिस इज जस्ट फॉर इन्फॉर्मेशन एंड अपडेट सर। थैंक यू।
देखिए सर, आप बिल्कुल सही है। एज ए रेगुलेटर जो आप कह रहे हैं वो बिल्कुल सही कह रहे हैं। मैं तो एक आम शहरी के लिहाज से कह रहा हूँ, हमें तो फाइन लगाने की ज़रूरत ही नहीं होनी चाहिए। हमारा सिस्टम ऐसा होना चाहिए कि उसमें फॉल्ट्स ना हो, लोगों की जानें ना जाएं। ये तो एक ना होने वाला वाकया होना चाहिए कि बिजली की वजह से जान नहीं जाएगी, ठीक है। तो उसको एक फाइन होना, वो किसी की जिंदगी तो नहीं वापस आ सकती, वो ठीक है। आपके एज ए रेगुलेटर आप सही कह रहे हैं, लेकिन आई थिंक वी नीड टू डू मच मोर। और इसमें बात असल में जो मैंने कही वो ये है सर कि रूल्स बने हुए हैं हर किस्म के। पाकिस्तान बिल्डिंग कोड भी है और पाकिस्तान सेफ्टी रेगुलेशंस भी हैं, अमल नहीं होता उनके ऊपर, और सारा मसला वहीं से शुरू होता है जहाँ पे चीज़ों पे अमल नहीं होता। इलेक्ट्रिक इंस्पेक्टर के पास इतनी पावर्स हैं एज पर द इलेक्ट्रिसिटी एक्ट कि वो चाहे तो यूटिलिटी को भी बंद कर सकता है, लेकिन वो तो फैक्ट्री को नहीं बंद करता। इसी तरीके से वी एज वी नो इट, बॉयलर इंस्पेक्टर के पास कितनी पावर्स होती, उन पावर्स पे अमल नहीं होता। थैंक यू सो मच।
मैं वो आपकी बात पे कहना चाह रही थी, जो हमारे वाइस चेयरमैन साहब हैं, ही इज हेडिंग मॉनिटरिंग एंड इन्फोर्समेंट, जो हमारा मॉनिटरिंग एंड इन्फोर्समेंट को, एंड स्टैंडर्ड कम्स अंडर दैट। और हम लोग ही इनकरेज्ड अस सो मच टू रिवाइज द स्टैंडर्ड्स। एंड जैसे आपने बात की ना कि कई चीज़ें हैं, कवानीन बने हुए हैं, लेकिन उस पर अमल, उसकी रिपोर्टिंग एंड कंप्लाइंस को वी आर ऑलरेडी वर्किंग ऑन दिस। एंड इसमें ये जो एक हेल्थ एंड सेफ्टी भी एंड सोशल पार्ट जो है, दैट वाज स्टिल मिसिंग, एंड वी आर वर्किंग ऑन दोज लाइंस कि हम किसी तरह सोशल पार्ट को भी इंक्लूड करें और फिर इस तरह के स्टैंडर्ड्स बन जाएं कि ये उस कोई और तरीका ना रहे अदर देन गिविंग कंप्लाइंस टू दैट। तो वी आर ऑलरेडी वर्किंग ऑन दैट।
वेल, ऑल द बेस्ट। थैंक यू। थैंक यू।
Pointed out that we should go and amend it.
Sir, excuse me, sir. Sir, yeah. So we are running out of time, and our guest has to leave. Our the vice chancellor also has to leave for Karachi. So,
I'm just saving time and not asking Falak Naz to invite me. I'm coming on my own. So thank you very much, everybody, and we have very interactive session. We have today people from private sector, people from regulator, people from the independent citizens, people who are the consumer, who are the customer. Everyone is on its own is also consumer and customer of this electricity. And I think the universities are the platform where we need to speak our mind, and then we think about some solutions. And this is what the aim of our also, that we have today private sector. So instead of defending what Khalid Parvez says by the regulator, you should listen it. You should rather absorb it and then see that how we can come up. I think the very thing which he has pointed out is that 1937 Act, why we have not done anything on that? Instead of looking at how we can actually compensate with 500,000 to the people who have died, why they died. I mean, this is happening everywhere. Yesterday we have a railway network, and I wonder, I told DS Saab that पूरे इंग्लैंड में हम 4.5 साल रहे, कोई एक बंदा भी फोत नहीं हुआ रेलवे एक्सीडेंट में. यहाँ हर साल 100 के करीब लोग मरते हैं, and then we realize we are still living 100 years behind the developed world. So I think the biggest issue is the implementation. We have wonderful policies, we have wonderful laws, but implementation. And I'm very happy that Rafiq is being our graduate, our alumni, is taking lead in coming back to the university and bringing these ideas. I'm also thankful to Irfan Saab, who is a friend of Mehran, I must say. Whenever we have any activity on the IEEE platform or from any other activity, I remember that we were sitting in IT Endowment Board meeting, and Irfan Saab has given this idea of bringing wind data as a CSR activity, and this is how we conceive the project and we move forward. And because of his initiative and Dr. Bhavani initiative, today it's a reality. And we have already heard Saqib Saab that the ugly face, not so ugly face of the capitalist, but that they are providing this data pro bono without any cost. And this is very rare. I mean, the private sector never give you, there's no free cup of tea. Business is business, cup of tea is a cup of tea. But yes, here is a cup of tea free of cost. So thank you, sir. And again, thanks to Irfan, he convinced the owner. And when the owner is willing to do anything, he can do anything. He's the boss. And I must acknowledge Khalid Parvez Sahab. He was my teacher way back 84, 85. He taught me one subject which I never missed, logic design and switching theory in 6th semester. And he was the first teacher who introduced open book examination in our subject. He said that bring all the books, all the assignments, all your notebooks, and that examination was held in the drawing hall. We have given a bigger drawing board to sit, to keep our books and everything. And he said that now you do the exam. And that was quite a unique, because and that helped us, because when we went to England, when I was doing my MSc, there were a lot of open book examination. Even they have given a couple of days to carry out the exam, the open book exam. And this time we have also done the same thing for our master's student. We have given them open book examination and we given them 24 hours to carry out the exam. So I think this was the first time I heard from Khalid Parvez Saab. And I also acknowledge her wife, Madam Taira, who taught us mathematics. She was a wonderful lady teacher of the mathematics. And my mathematics is considered to be the strong mathematics still today. And that is because of those teachers who have been taught us. And I'm really happy to see these teachers who are actually parents and the teachers, they are actually building your life ahead. And we are fortunate that we have got wonderful parents. And I completely agree that Pakistan requires implementation. Policies bani hui hain kafi, lekin implementation aur uske liye koi mechanism ban jaye, uske liye koi tarika ban jaye, so we'll be very happy to. But nevertheless, this is a long discussion. CSR itself is a very exciting thing. Yesterday I was having a dinner with HBL, and their country bank director came in Karachi and in Hyderabad. So he invited us on a dinner. And you see, Jamshoro is probably a bit place which is considered as an isolated. Yet, although in Karachi, people sitting from the Karachi, they must acknowledge that if you go from NED to Maripur, it will take same time coming to Jamshoro. You need 1.5 hours. Today, this very morning, I have a briefing with PEC delegate. So I was here at 9 o'clock and I left around 10 o'clock. I reached 11:45 at Korangi, an institute where I had a meeting. And then I left 1:35 from Karachi back here, 3:30. So it's not that big time, yet we consider it as an isolated place. And whenever there is a CSR activity by the private sector, it is always Karachi, not Jamshoro. We are also having this wonderful university. And only time we manage get one CSR fund from HBL throughout the history of all 3 universities in here. This is Jamshoro, the education city. It has around close to 50,000 students. Now it has 4 universities. We have around 8 to 10,000, 35,000 in the University of Sindh, which is a general university. 5,000 plus is in this Liaquat University of Medical and Health Sciences. Recently, a new university, University of Arts and Heritage, which is focusing on arts. It has around a student close to 500 to 800. And then there is a private university, University of Arts, that has also some number. Then we have a cadet college, Petaro, which is also a huge establishment, very old establishment. So this city has more student population than the local population. And now with connectivity with Karachi is so fast, we really need private sector to offer these internship to us, offer these, and Rafiq, I appreciate, he has offered us how we can actually legislate, how we can actually, and when we are in PEC, I was at Board of Governors for more than 6 years in PEC. Still tomorrow there is a meeting of Vice Chancellor's Committee, which we will attend. We have floated this proposal of internship for the student. We said that we have 20,000 के करीब आप हमें हर साल, क्योंकि इतना नंबर इंजीनियर्स का निकलता था, 10,000 ऑर्गेनाइजेशन खुद दे, 15,000 गवर्नमेंट टॉप अप करे, या 15,000 ऑर्गेनाइजेशन दे, क्योंकि वो वहां काम करेंगे 6 महीने. अगर विंड टर्बाइन पे इंजीनियर कोई भी काम करेगा तो उसको आप पेमेंट करें 15,000 और 10,000 गवर्नमेंट टॉप अप करे, तो 25,000 इज ए वेरी स्मॉल अमाउंट, येट इट इज सफाइस for them to survive for 6 months. There are baghair paison ke internship after graduation is very difficult. And remember, let me tell you very honestly that these universities which are in public sector, they are really serving poor and intelligent students. Good private sector universities are serving rich and intelligent. It's only the private public sector universities which are serving intelligent and poor. Now, we feel that it is our right to have this CSR money being spent here. And in the last many years, even NED is serving very well. It is now having Compass and Thar. We need actually support from the private sector for. But when the CSR money, it goes to lumps. When the CSR money comes, it goes to Aga Khan University. When the CSR money comes, it goes to IBA Karachi. You know, during Dr. Shirsen's time, some 10 billion rupees came through these donations and CSR money. I mean, IBA is a rich institute. They charge like private sector, yet they receive the highest funding from the CSR because their bosses are from the IBA Karachi. So I think we need to change that psychology. We all also need, and we need legislation. Otherwise, we will not be able to get our share, our rightful share. We are not asking any bigger thing from them. The share which we have, the graduates which we are, our graduates who are serving in the communities, in the government or private and public sector, they deserve their CSR back to the university. And this is also, and in our society, unfortunately, CSR is considered charity. हमें भी जितने पैसे मिलते हैं स्कॉलरशिप में मिल जाते हैं क्योंकि उनपे सवाब होता है, लेकिन यूनिवर्सिटी के रिसर्च प्रोजेक्ट में नहीं मिलेंगे क्योंकि उसमें सवाब नहीं होगा. हम अल्लाह के लिए दे देते हैं लेकिन अल्लाह के मखलूक के लिए देने के लिए तैयार नहीं है. लेकिन we need to change this mindset. And this is a wonderful opportunity. अगर जॉब क्रिएट होगी तो क्या गुर्बत कम नहीं होगी? Why we want to give charity? एक खाना टाइम का खिला लें, इसको कोई रोजगार दे ताकि वो लॉन्ग टर्म बेनिफिट होगा. वो सदका जारिया है ना, कंटिन्यूअसली रहेगा. We need to think CSR different way. And again, हम सोलर सेल बना सकते हैं, नहीं बना सकते, विंड टर्बाइन बना सकते हैं, नहीं बना सकते, I don't know. लेकिन हम कंक्रीट पोल बना सकते हैं. So let's look at those things which we can do. Forget about what we cannot do. यानी 60% आपकी कास्ट बचेगी. Government has a plan to invest 200 billion in the next up to 2030. अगर हम 60% कास्ट अपने लोकल रिसोर्सेज पे लगाएंगे तो हमें फॉरेन करेंसी में 120 बिलियन की बचत होगी. I think that's the biggest challenge for us. So we need the investor need to look upon that. कि हम उन छोटी चीजों में लगाए, कम से कम ब्लेड अभी बेशक वहीं से ले आए, क्योंकि सोलर सेल इज नॉट इजी टू मैन्युफैक्चर. आई एम सॉरी, इट रिक्वायर लॉट ऑफ, एंड बीइंग न्यूक्लियर कंट्रीज वी हैव लॉट्स ऑफ रिस्ट्रिक्शन. इवन सोलर सेल में कुछ एनालिटिकल कुछ टूल्स ऐसे भी होते हैं जो कि न्यूक्लियर में यूज होते हैं. सो वी कैन नॉट गेट वेरी फ्रीली these testing tools for the solar plates to be manufactured here. But yes, we can manufacture some of the accessories thing. Problem तो ये है कि हम ये पिन जो है ना, ये बन रही है ना, ये भी चाइना से आ रही है. ये भी चाइना से आ रही है, despite having the textile. Think about those things which we can really do. Start doing the things which we can do. Forget about जो हम नहीं कर सकते, वो हम कभी ना कभी कर लेंगे इंशाल्लाह. उम्मीदों पे दुनिया कायम है, हम भी इसी आसरे पे जिंदा है, कुछ ना कुछ हो जाएगा. लेकिन we need to really start doing the things. छोटी छोटी चीजें कर ले. And I tell you honestly, my sister is a professor in Jinnah. Yesterday she told me that while I was coming from the CPSP college, people are appearing in the part 2 exam, they are throwing tissue paper on the ground. I think we need to change our habits. We need to think differently. We need to do small little things. They make an impact. At least we should not be polluter. We cannot reduce the polluter, but at least we should not ourselves be polluter. And this is why they say, if you are not part of the solution, at least you should not be part of the problem. I think if we only focus on these things, we can really bring changes. Thank you very much, sir. I'm sorry if you, I always talk, प्रोफेसर होने का थोड़ा सा नुकसान भी है या फायदा है कि हम बोलते इसी तरह है, कभी कभी थोड़ा सा टफ हो जाता है, लेकिन दिस इज हाउ वी आर. थैंक यू वेरी मच.
Thank you so much, sir. Whatever you said was so right. Okay, I would request Sir Tanveer to kindly come on the stage for a word of thanks.
Bismillahirrahmanirrahim. Just, I need attention, all of you guys, please. I especially wanted to thank the chief guest of today's event, Mr. Rafiq Sheikh, Vice Chairman NEPRA, our Honorable Vice Chancellor, Professor Dr. Muhammad Aslam Uqaili, who just came, as he already told you, that he had been traveling from Karachi to Jamshoro for a couple of times on this same day. And Mr. Irfan Ahmed Saab, Sir Saqib Saeed Saab, the officials from ActWind and the officials from GoldWind. I'm sorry to say that today Mr. Yang, who is the country chief of the GoldWind, he was supposed to come here to attend this event. But because of some security reasons, he could not get clearance and he could not join us. So anyway, I'm especially thankful to the officials of ActWind and GoldWind who just attend this event and bless this occasion. I'm especially thankful to all the team members, our respected faculty members, and I'm again very much thankful for the presence of IEEEP chairman, who is also the teacher of our Honorable Vice Chancellor. Sir, thank you very much for being with us over here. So it's a great honor and for being with us. I'm also thankful to Ms. Huma, the consultant, CSR consultant. I would add one more thing, what Uqaili Saab has been telling you about the CSR activities. Although, because I'm mostly involved in the students recruitment and other activities like internships and so on. So I've just felt one thing, and most of the industries who are Nooriabad, Jampir, Jamshoro based, the students from Mehran University, they get less salary as compared to those other university from bigger the names which already been taken by our Vice Chancellor. So it is really a little, if make us feel a little discrimination. So being a CSR official, we request you to please do not differentiate while appointing any student from one university and another. You should mark the salary depending on the performance, not on depending upon the label, brand labeling. So I would again thank you very much all students, my respected faculty members, dean, मैं सबका नाम नहीं ले रहा क्योंकि स्टूडेंट को बड़ी रश हो रही है, खान जी साहब and our director finance, Dr. Ina Bhatti साहब, Bhavani साहब, and Chuktai साहब, and I'm honored to say that Dr. Sain Chuktai साहब is also my student. He is my student in PhD study. Thank you very much all. Nice for being here with us.